Still sound American? Oh dang, I was going for New Zealand. Go for Welsh? Why would I want to sound stupid? Damn. Yeah, Luke said, if Zach didn't have a chance to help you out, feel free to let me know. It's gonna be a struggle for me, but I can try. I'm not sure people are gonna be around today for the reading group, but even argue with that. I mean, I can't say American sounds particularly smart. Reading by, you know, honestly, I'll take that. People usually say math by. Let me hop into the Discord. Let's see if anyone joins in. I'm not sure people are going to be. I know at least one person will be able to show up. I don't know if Fembox is feeling better or not. But either way, we're still going to talk about whatchamacallit, complex analysis. Today's Tuesday, right? I feel weird for some reason. Okay, yeah. Wait. Oh shit. I started an hour early. Funny. Okay. That's well, there's your problem. Okay, let me. Well, fuck. I forgot. I start this shit at 2. And it's 1. Okay. Uh. Okay, let me just update some stuff because I don't know my own schedule, evidently. Waffle! Holy crap, how have you been? Oh wait, I saw you in someone's chat, right? Either way, it's good to it's good to have you. Should I update the YouTube? I'm just gonna leave the YouTube as it is. Fuck it. I only update the Twitch title. Hey Desson. Zach stream. Okay, right. Summary back on Twitch. Well, we're glad to have you. I accidentally started the stream early, so I gotta figure out what I'm gonna do now. I could go back through this proof again, I guess. Let me get music going. Okay. So we proved this probably sometime last week on stream. But the proof kind of has some subtleties, and well, I don't know. I don't know if I want to go back through it right now. I kind of don't feel like it now. Was there anything from chapter 1? I don't want to do anything from chapter 2 until. Well, there's some Diffie Q stuff we could do. What's number 8? Is Aid saying that like there's a unique polynomial for each curve in a region? Sundelta's back. Yeah, if you have any questions about that, Lucas, feel free to let me know. I started the stream early because I'm dumb, so I have 50 minutes before I would start the actual reading group. But if Zach helped you out, then all the better. Hey, Sage. What would these limits do for us? You passed your math final. Past 2 weeks, so you've been done with college ever since? Oh my god. Congratulations, Sage. That's awesome. Well done. Vitamins start an uprising against the government. Yeah, waffle. Number 8 just feels weird. I don't know what they're getting at with those limits. You know what? Let's try 5. Hey, Syncult. Let's just go to chapter 4. Sounds like a great idea. I definitely shouldn't spend any time studying the prerequisites. For number 5, I don't think they want us to use Cauchy Riemann. So let's try and work it out from the limit definition of a derivative. On break for now. Yeah, fair enough, Sage. So we could think of real part of Z. I mean, there might just be a way to do this directly. Maybe, no, okay. I was going to write something like, we could think about it as like Z plus Z conjugate over 2, I think. That might not be a helpful representation, but I have that in the back of my head. That's a very specific time, Sandculp. I don't know. I don't know what that's supposed to mean, but you can if you want. I think we just use the fact that real is linear and probably not have to worry too much about the thing that I wrote in the upper right. Because we could split this up into 2 separate reals, and then the real part of Z will cancel the real part of Z. So we get just the real part of delta Z over delta Z. And so we could think about polar form, maybe. Yeah, I think we're probably, I doubt we even have to do that. The point is that as soon as we start changing the imaginary part, like we can get 2 different results if we approach along the real axis versus along the imaginary axis. Well, yeah. Yes? Yeah. But this might be more clear in polar. So if delta z is equal to r e to the I theta. I guess we want to say r cosine theta, to be honest. That's the real part. Gold. Yeah, I just learned about, or I mean, I've learned about them before, but in the book I just got to the Cauchy-Riemann equations. But this particular problem is from the chapter before they introduced it. So I think they want me to do some funky thing with the limit definition of a derivative. Carl, I don't know why. So in epsilon delta, what you do is that epsilon is for y and a real number. Delta is for x and a real number. Right? Yes. R is for y and infinite. S is for x and infinite. The infinite part, I didn't learn that convention. I don't think I've done an infinity proof for epsilon delta. That I can confirm the first part of what you said, Lucas, about epsilon and delta. R and S, you're probably being taught it a certain way. That I wasn't taught. Yeah, honestly, Gold, like I know conceptually like what epsilon delta is saying, but when it comes time to actually do a proof, I get so lost. I struggle pretty hard with epsilon delta proofs. Color cone? No. So all I did, I used to have my mic like way out here. Oh no. Oh, I just, oh. And I just thought it was better because like the P's and the S's were pretty bad if it was up close, but I was actually playing Daisy yesterday. And someone asked me if my mic was far away and told me to try keeping it close. And so I figured I'd just try doing it this way and see if it's better. So yeah, I hope that this is an improvement. I think I'm gonna want to get a pop filter. Hey Eldritch. We need epsilon delta intervention therapy. Waffle, what in the world is an epsilon delta? Hey, Shrija or Shriya, maybe? Thank you. Epsilon delta, Waffle, is you learn about it potentially in your first calculus class, more commonly in an analysis class. If you have ever seen like the idea of a limit, like the limit as x goes to 2 of x minus 1 over x minus 2 or something, I just made up a thing. Epsilon delta is the formal definition of a limit. It's really proofy and it's really annoying to learn. The sock strat, yeah. Fuzzy handcuffs for a pop filter. Then they have several uses. You know, Phobos? That's a genius idea. We got to be more sustainable in the world, and finding multiple uses for things like that is kind of perfect. So yeah, if you're in like Europe, like Lucas is, you probably learned it earlier. In America, at least, I was shown it in a calculus class in college, but I was never forced to actually learn it. I only would have had to learn if I went to the analysis class. It's honestly, it is kind of fancy. But like whenever in calculus we do a calculation of this is just kind of in the background. You're actually doing epsilon delta, like you're relying on results from epsilon delta. The sock strat. Yeah, for this bike in particular, there's a pretty cool looking one that it's an AT 2020. The same company makes kind of cool looking like metal pop filter. Oh, nice. Welcome in Shrija. I'm sorry if I'm pronouncing that wrong. Watching red pen, blue pen, 5-hour videos on Epsilon Delta 10 times, you'll be fine. No, no, black pen, red pen. I really like his YouTube channel. For a while he was actually doing on YouTube math help streams. But this dude, really fun, like calculus videos. Yeah, he's a pretty big channel. Yeah, he'll do like challenge it integrals. He has some like more tutorial videos too, but like I've seen where he integrates square root tangent. It's pretty crazy. But yeah, his videos are fun. I think he's, oh my god, it's like Stanford or Berkeley. He's based at. I can't remember which one. Okay. Anyway. Well, what was the point of me doing this? So if we've talked about the limit as r goes to 0 of r cos theta over r cosine theta plus I plus I sine theta. The r's are going to cancel out, and this limit is going to depend on theta is the issue, and it shouldn't depend on theta. Because we can choose different values of theta here and get different results for the limit is the issue. Patrick JMT. I haven't heard of him. He makes engineering videos? Why are you all people watching engineering videos? Oh, stats? Okay. Rex, hello. Hope you're doing well. A lot of stats so far. There's some linear algebra. Ooh, circuits. Okay. Oh man, that actually sounds kind of cool. Chemistry. I don't really know chemistry AD. I'm sorry. It seems like a good channel. Not having watched any of his videos. Olive Community College Math. Wow. Oh, true. Aditya. You can try Dr. Gold, who usually streams, I think starting, oh my god, on Tuesdays. I think 2.5 hours. I think I have a command. So yeah, if you have a chemistry question, you should try actual education in 2.5 hours. Yeah, I'm gonna have to look at some of this guy's videos. What? I didn't mean to click on that. Slim, awesome. I accidentally started my stream early, so I'm just kind of wasting time for another half an hour. But yeah, that's awesome. Yeah, yeah, but he's going live in 2.5 hours. He goes live on Monday, Tuesday, and Saturday in American time zones. That might be a day forward for you. Living Gold shout me up take chem? You should. Yeah, Jed. I hope the mic sounds better here. It is pretty like prominent in the camera though. So I don't know. It's a trade-off. Yeah, I'm sorry. The time zones are kind of rough. Grad school ventures. Oh, I guess I haven't told you. I'm gonna be going to the University of Washington in Seattle starting in the fall. For a master's in applied math. So I've been kind of selling off my stuff. I need to sell off some more stuff. I've been lazy about that. But I'm gonna have to move in the next like 2 months. That's true. I am I should be recommending your YouTube channel more, Slim. Yeah, I'll still stream, just not as much as I am now. I should just get your YouTube channel on a command. I feel like a physics PhD, UCLA proof to help you. Yeah. Boy posting soccer mom questions though. American Times was maybe a bit vague. Oh yeah, I mean, I was just saying that because Adia said that they're in India, so I figured it wasn't too important to be that specific. So you're better than California with funding? Oh, really? Honestly, I know that funding stuff is happening. I haven't been following it that specifically though. Dropped a new video yesterday. Ooh, nice. I'm gonna be living within walking distance of campus if all goes well. I was gonna try and get into the actual like grad student housing they have there, but it seems kind of it's hard to get into and it seems overpriced. So up in the area doing a campus visit in late July. I wasn't planning to move until August or September, unfortunately. Are you gonna be up in that area? Every single seminar, that'd be nice. So much time programming an inverse function for a harmonic numbers principal branch. It's way easier and you did it a stupid way. Okay. Syntax. Hope you're doing well. Harmonic numbers. I just learned about harmonic functions, I think. In like a complex context. Grad school housing is a scam. It seems like it. It seems like I'm way better off just renting. Normally. Customers in the area around that time. Yeah, that would be awesome, Jed. To be honest, I haven't really planned it. Like, since I only just recently decided not to go for grad school housing. And so now I can move whenever I want in theory. I could move like right now. I kind of just haven't really wanted to. But I don't have a very like firm plan yet. It'd be great though, Jed. Like if you're in the area, I'd love to get dinner with you. If the timing works out, and that goes for like pretty much anyone around here. Then like, oh, your streak got cut. That's stupid. Twitch will do that. Was it doing anything weird? Oh, it might have been. I think on Wednesday I streamed at an unusual time. It might have been because of that. Rent is theft? Yeah, it kind of is. Yeah, on Wednesday last week I streamed in the morning to play with a Dutch friend. Two of my future camps the day I was at the mandatory military check-in thing. Wait, so you missed it, Syntax? Prepare to learn what you learned in the last 10 years, but in a semester? Yeah, it doesn't. I'm kind of nervous about the pace. The entire master's takes place over a year. And it seems really fast-paced. Mean Machine Rex, you want to see the applied, Drew? Yeah, sure. You have the 12 streak going, Jed. Nice. Yeah, it's usually 2 years, but Universal Australia is on the quarter system, and for whatever reason, you can just do it in 3 quarters. Yeah, Lucas, I was playing DayZ with a Dutch friend, Autistics Live. He's a cool dude. In that small math course group, I am literally the only one who will go to study there. Except for everyone else, it was useless. Oh no, Syntax. Don does master speedrun. Yeah, that was the only reason I could really go, financially speaking. The fact that it only takes place over 1 year means that the cost was cut in half compared to other schools. So even if I tried to stay local, if I was paying full to or like if you compare like full tuition to full tuition, it seems cheaper to go to Washington because of that 1 year thing. This is Rex's Apple. Why is my Discord taking up the entire screen? Mega Discord. That's a nice apple. That's a way better apple than I could draw. Please don't run the 90% category. Yeah. That's like all cheating allowed. I think the program is DayZ or Factorio. It's great advice. It's in Seattle. New and is too hardcore to draw. Oh, the buttermilk biscuit. Your sister just took a job in Seattle? Oh, awesome. Yeah. I would love to meet Twitch people. I don't think I've met anyone. No, I don't think I have. Abusing exploits alcohol in your bachelor's program. So yeah, I guess anyone's just joining. Today's a reading group day. For complex analysis. I just forgot that I start those streams an hour late. So I'm just killing time for another half an hour until it's time to start that up. Yeah, I honestly, like, there's a point they literally just had the submissions for TwitchCon panels, and for a few days I was really thinking that we should submit a proposal. I kind of came to the conclusion that I don't think it's not necessarily going to be that significant of a thing for the math community, so I kind of dropped the idea. But I think going to TwitchCon would just be like a super fun thing in general. I just would probably want to wait a year if I were to do it for fun. Hey Jasper, you were taking this class. You weren't anywhere near ready. Oh no, that could be pretty brutal. Aditya. Ooh. This looks like a competition question. But yeah, Fizbus actually been to TwitchCon, so I was like asking him about it. And apparently there are a fair few panels with smaller streamers on there. Like 500 to 1,500 followers. I would just kind of be afraid of not getting good turnout. Especially if there's math in the name of it. I think people just kind of wouldn't want to hear about it. But it's also probably not super likely to get accepted if there isn't a partner or someone who's a little bit bigger on there. Free feet pics. Maybe that'll entice people. Don't hit your toes. Yeah. There's a theorem about this, you think, syntax? It's in San Diego too this year, so it wouldn't be that far from you. There should be more feet pics in math textbooks. Jasper, that is a great idea. I want to read a math textbook written by you. Math hot tub stream. Honestly, I would actually do that just for the memes if I had access to a hot tub. I think we can split the sum. What's happening here? U sub n are the complex nth roots of unity. Alpha is 2k pi I over n, denote a primitive complex nth root of unity. I don't know what the primitive part means, but okay. Include a ruler to prove it. Yeah, there will be more feet there. Here's a strong point, Jed. What the hell? Is equal to n when n divides s? Or 0 when n does not divide s? With Margot Robbie. So this is a series definition for a root of unity? Nobody wants to see decimeter pics. It might not be used here? Okay. For a non-zero complex number z, let argz denote the principal argument of z. From minus pi to pi. Oh, okay, so it's like the first root. Okay. Math hot tub stream discuss Navier-Stokes and how it can represent the flow of the water in the hot tub or something. I think that's what Navier-Stokes can do. I don't know. Omega be the cube root of unity. Cube root of unity. Okay. So they're asking for the arg of the sum. Ooh. Ooh. Okay, let's go through. You don't know why wrong. What did you do, Adia? Reynolds stress of the vortices. Is this a JE, Yash? This one's at least better because I'm checking someone else's work and I don't have to do this from scratch. But yeah, I really don't like JE. Wait. Oh, this is a finite series. Okay. Solving Navier-Stokes for Ed Sheeran inside of a hot tub. Obi, hey. I thought this series was going to be a problem, but it's finite, so we don't have to worry about stuff like this. Niamo song from Andor. I haven't watched Andor. It's just like a regular like synthwave playlist. Hey, Ashu. Mon Mothma Death Dance? That sounds badass. Season 2 is goated. Okay. Ooh. To the cute? Wait, okay. Oh, they do sum to 0, don't they? Yeah, okay, that makes sense. The imaginary parts cancel for the... And then the real part... Yeah, okay. Oops. And so if you go out to 2025... Oh my god. Destin, it's not even that JE questions are that hard. They just use the world's most vague trig identities, or just identities in general, and I just really hate them. They're solving them doesn't make you smarter, they just make you better at memorizing things. Does 3 divide 2025? Oh yeah, and anytime a geometry problem requires you to like draw an extra line, those are they get really difficult. Oh, you know now, Aditya? Okay, that's good, because I was still reading through your work and I hadn't made much progress. Yeah, in case anyone didn't catch a big stream, I am like trying out a new position for my mic. I hope it's an improvement. I have to remember to actually like sit up straight and be in the same spot, which will be annoying, but if I can get in that habit. That will make 0 the second one. Yeah, I was just questioning if it, I was trying to figure out if it would end on Omega cubed. And if it did, that should just be 0. Can I do a backflip? When I was a kid, I actually could, kinda. Wait, could I? No, I think I'd do a front flip. Maybe not a backflip. Okay. Yeah, if that was the error, then I'll drop the question. Like I said, I didn't do much to help you, Aditya, but I'm glad that you spotted it. When the Nobel Prize in Physics random JE question and ceremony appears by the public. Yeah. And then Dark Souls music starts playing. Arg 0, 0, the whole answer becomes 0. So wait, does 3 go into 2025? 2 plus 2 plus 5 is 3. Sorry, it's 9, which 3 goes into. Yeah, this is annoying. That shouldn't be 0 then. I see what you're saying. So I know for a real geometric series you have the formula, I forget what it is for finite, but it's something like that. Like, I assume this still works in complex. Can we just like try doing that and not thinking about the cancellation? Where can you send you a solution? You solved it? Oh, if you're in the Discord, that's the best place. Oh, I guess the radius of it is equal to 1 though, is maybe the issue. This is where the question is posted in math homework help in OK Man Jesus thread. Someone's saying it should work. Okay. I did get the formula slightly wrong. I see. It's r to the n minus 1? Really? No. Oh, I had it right. Okay. Gojira, they're a French metal band that I really like. So what is the actual cubroot of unity. It should be pi over, no, 2/3 of the way through. So 2 pi over 3. I'm just trying to solve this geometrically. Is it just that? Yeah, I think it's that. Okay. That's what omega is. You have the minus before. Well, I guess Adia did the minus separately. I guess there's no reason we can't do it with minus omega though, right? Oh, really? It's not valid to split up the series? Interesting. Okay. You're saying it changes the sign of the exponent if we do minus omega? Entity, hello? Oh, I guess I see that. Okay. It adds pi. I mean, isn't that equivalent? Did I ban you before, Entity? I probably it's really easy to get banned on YouTube. A yellow jacket? Oh, there is a fly that's been buzzing around. Oh wait, no, you mean a literal jacket that is yellow. Never mind. Wait, if it pi plus 2 pi over 3. Oh, the wasp kind, okay. Dot 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 dot. Why is my mind 5 pi over 3? Color cone, yeah. Gojira is French. What time is it? Okay, we got another 10 minutes. Anyway, if we apply this summation formula, I think A is just 1. Why am I? I think because I think. You can post the solution in math homework help in my answer is wrong, like posted by OKManGs. Um, 2025 divided by 3, 6, 7, 5. 675 times 5. There has to be a better way of doing this, right? There'll be 4 pi over 3 as well. I'm not sure, Obi. I'm getting a little bit confused with what exactly minus omega is doing. Yeah, Japanese. We need to know if it's odd or even. That's true, Slim. Yeah. This is basically like e to the I pi. So it's 1 minus minus 1. On the bottom, something annoying, I guess. Cosine 5 pi over 3. Dude, I can't visualize the unit circle right now. I'm just gonna Google it. Me too, Sandcult. Me too. 1/2. You're saying it is 4 pi over 3? That is annoying. Let me see what the answer to this gets. We can always back up, I guess. Day by day. Right now I'm working on complex analysis question. What overlap this has with all the control courses I've taken. Entity, please stop. Transfer bode plots, zeros, poles. Just I don't quite know what cybernetics does, so I hard to understand what the connection would be. But complex variables can be used for like circuits. Yeah, I know. I'm sorry. I'm not sure what the connection would be with cybernetics, but it's just a complex number question that someone asked. I'm not sure if I'll be able to solve it though. But yeah. So how's I negated the angle because if you have a complex number here and you multiply it through by -1, aren't you reflecting through the origin? So you're going to end up down here. So I just made the angle negative, which actually that doesn't work, does it? It should be adding pi. Yesh sent a solution. Maybe Bolzano wire stress theorem you're learning about, Lucas? Physics explained. I'm from America. So use the same formula. Is the first term minus omega, Yash? Huh. I thought there would be something in front of it. Oh, never mind. It starts from 1. Never mind. Okay. Oh, that's like, yeah, we learned about it as like intermediate value theorem, I think. Okay, so yeah, I definitely messed this up. Um, and entity, you're being weird, and I don't really have the patience. Okay, I'll add the person who posted the question here. I'm just a student. Hey, Nokian. Programmers play math. Yeah. I'm just a student. Is processing planes, stabilizing drones. Hmm. Yeah, I mean, there might be a connection here. I would think of more like discrete math as being similar. Yeah, that's fair enough. Day by day. Oh, I see what's happening. Okay. Two over omega. Huh. All right. Nicely done, Yash. Yeah, it's easier when you know what the solution is. Okay. It's 2 o'clock for me. Uh, Rian, ew. I might be able to do that question, but not right now. For the next 2 hours now, I'm gonna be doing a reading group that I've been doing on Tuesday. Um, I'll copy your question down though, and if you're not here when I have time to look at it, you could check the recording. But I'm gonna switch gears here and not do math help for a little while. I'm gonna be starting on a master's. Okay. Let me switch to Twitch title and category. Or not category. What is this chapter called? It's the last question for now, Japanese. Yeah, for like 2 hours or so. Second part of the question asking for the minimum dimensions. Okay. I'll copy that down too. All right. See ya, Adia. You have a good day too. Okay, so anyways, here for the complex analysis reading group. I'm going to jump in the Discord. Because this is what I was actually supposed to be doing today, but I just started the stream early by accident, so...
Hi, Don.
Hey, Fembucks. Glad you're able to join.
Yeah, thanks. Feeling better. Things picked up a couple days ago, and I guess last night things picked up a little, so I'm feeling better.
Awesome.
Glad to be here. Although I just realized 2 minutes ago I haven't read this chapter yet. So.
Oh, okay.
Yeah.
So the Discord call right now is just for those who are going along with the reading group. Let's see, for chapter 2, we were only doing 2.1 and 2.2 for this week. So they start off by deriving the Cauchy-Riemann equations, which isn't too bad. They do a really funky thing involving... Oh wait, I need to do my message pin. There we go. They say we use a well-known result of real analysis of two variables to make a weird statement with delta u's in equation 2.1.5. And I wasn't quite following what they were doing in this, like, math, to be honest, but...
Yeah, it's some kind of two-dimensional continuity. Is it 2D continuity or 2D limit or something?
I guess so. They're not really speaking about what epsilon is.
I would think it'd be the radius of a circle, but
it looks like some type of like approximation from the delta parts, and then the epsilon is some type of correction or something to get it exact. I guess like some tangent plane business.
Oh, yeah.
That's what I'm thinking.
Yep, that sounds more like it.
It's Taylor theorem, Caldercone says. Oh, okay. Because it didn't really like name what it is, so I was kind of confused on what to try to Google for this. That's something to look into, though. The point of this, what was the point of this? To show that it's sufficient.
It's like a tangent plane.
Okay. But the overall point is... Okay, and with my mic being in a different spot, I hope that Discord won't cut out as much. Let me know if it does, though.
Okay.
I think the thing that they're trying to prove is that if the partials of u and v exist, satisfy the Cauchy-Riemann equations, and are continuous, then the function must exist and be differentiable at that point, which means that it's sufficient. Is apparently what this proof is, I guess. epsilon and epsilon 2 are functions that go to 0 when z goes to 0. Okay. Ren just streamed for the first time in a long time. He's a cool dude. As far as I know, they're the same thing, Ren. I don't know if there's actually a distinction. 2 dawn and 5 dawn. Okay. Okay, yeah, so that part's a little bit weird, but I think I get what they're at least trying to do. First time streamer. Oh, okay, so this one was a constant question for me, which is and I know you didn't read it, so but they're saying that the level curves of u and v are orthogonal. And somewhere else they said they're orthogonal at every point x and y. They don't say it here.
Oh.
But I don't know how two things are orthogonal at every point. That doesn't feel like
It's a family of curves, isn't it? Does that remind you of like when we were in electromagnetism and we were looking at the equipotential lines versus what the other things were? But I remember they were always level curves, and they were always orthogonal at every point like that.
Right, yeah, because if you're orthogonal to the field, you're not doing any work. So that's where the equipotentials are.
Yeah. What was the potential? What was it? The potential was orthogonal to the magnetic field, wasn't? No, electric field.
Yes,
that's right. That's right.
There might be a similar thing for magnetism though, with the magnetic potential or whatever it's called, vector potential. I don't remember though.
I don't either. But I think that's what they're talking about.
Yeah, I was kind of confused. I guess I'll call it out when this phrasing happens. But like the idea of two curves being orthogonal at every point didn't make sense to me. It makes sense for them to be orthogonal at a couple of points. But
hey, I think I know how to think about it, Don. Here's a good thing. Just think about, here's a function I like to think about when I'm working with complex numbers. Just think of z squared, right? It's so easy. Just take the z and square it. But if you write it out as x plus iy, and you square that, and if you FOIL it out, what do you get? You get x squared minus y squared plus I times 2xy, right? So the u component is x squared minus y squared. That's a hyperbola. Those are hyperbolas. Well, let's say
they're both hyperbolas, but different ones.
And then the 2xy is also a hyperbola. And I think, let's see, but what do we want to vary here?
I think they do that exact example somewhere.
Oh, do they? Okay.
Or something like that. But like, and so I guess the point is that if you zoom in on the intersection really close, it's basically perpendicular where they intersect. I'm thinking so. And maybe if you change the ones to another number, right? If you make them both equal to like 10 or something, I don't know. But I think I think they're always at right angles. Yeah. It seems like it, no matter what the numbers are.
It looks like it, doesn't it? It looks like it.
They're different. No, that still looks right angle. But like a negative. No? Okay.
Maybe, you know what? Make one into a slider and like slide it along and see if it.
Oh, yeah. Seems like it checks out.
Yeah. So what do we have here? We have like the red curve is like the real part of z squared, and the blue curve is the imaginary part of z squared. So one of them's u and one of them's v, I guess.
Right. I guess technically there's a minus with the 2xy, right? We said that? No, there isn't.
Yeah, sorry.
It's x squared plus y squared. No, it's a plus. Even then with the constant, it doesn't matter, I guess. So yeah, like the way they're phrasing it kind of confuses me, but if the idea is just that wherever they do intersect, it's orthogonal, I guess I can understand that. Um,
I didn't know that. That's really neat.
yeah, and there's a way, or they show that the gradients are perpendicular too, which is just as good.
Oh,
If you take advantage, uh, if you take advantage of the Cauchy-Riemann equations, you can show that you get 0 for the dot product.
oh yeah.
Um, yeah, right. The gradient would be like pointing like outward, like in this for this part of the red hyperbole pointing to the right.
Hmm.
Um, I go through a bunch of steps to get Cauchy-Riemann in polar, and the derivative in polar. Hey, RG. Uh, Page 49. It's this book here. It's not particularly good, but it's good enough.
Got a cool picture on the front.
Yeah, it does. I have a reason to stick with this, which is I'm going to be taking a class that follows this book. So I'd be interested to hear your recommendation, but I'm definitely sticking with this book. Um, differentiable. Just seeing what else. There was a few other parts that were weird to me. I was trying to find where they are. Okay, I'll write that down somewhere. Put it on my freaking Journal Plus Plus, I guess. Best book for CA? Interesting. Okay.
You have a PDF reader that lets you annotate the PDFs.
Uh, Firefox would let me draw on this. Yeah. I never really played with
Yeah,
it.
I never really think of doing that, but I should make notes on it.
Yeah, I can't remember if I can save it when I do it in this one.
Because I'm always thinking when I'm reading them, I'm just like, oh, I got to remember to come back to this here and look at this again. And then if it's if it's a textbook, I'll put a little star. But if it's a PDF, I just forget to put a note.
Yeah, it would be nice to be able to like write little notes in the margin or something.
Yeah.
Um,
Okay. Okay. Here we go. So what's the difference between analytic and holomorphic? Maybe that page will tell us.
oh, it says that they're the same thing.
Oh, all right. Well, then we're no difference.
Yeah. It is kind of funny. They talk about singular points being where F fails to be analytic. And I just think that the naming is kind of funny because they then point out that Z conjugate is analytic nowhere and has singular points everywhere. So they stop sounding kind of singular. Like there's a lot of them.
Hmm.
But that's just a phrasing thing. Microsoft Edge can do that apparently. Okay. And we start talking about Laplacians, or like Laplace's equation with del squared of a function equals 0.
Yep. Bringing back more memories of E and M.
Yeah, I remember the book talking about this for something with equipotentials, I think. Um, a function that satisfies the Laplace equation is called harmonic. Yeah, that's true, RG. That it probably mean singular in that sense, not like single. Hey, Properva. What else do they do? Okay, so like, here's one place where they say two level curves are orthogonal to each other at each point x, y. And that confuses me. If you're holding C1 and C2 constant and varying x and y, they only intersect in two spots. So how are they orthogonal at each point x, y?
Oh, this is exactly the same thing I was just talking about.
Yeah, this is where it came up, I guess. Yeah, it seems cool, RG. So I'm really confused by the phrasing I guess at each point x, y. Like it's not every point, it's only certain points. At the okay, thank you for that color code. So I'm not crazy. I guess maybe they're assuming that x and y are the points that satisfy both equations, but they never said that.
Maybe they mean as like C1 and C2 vary, right? Because if we varied C1 and C2, kind of like sliders and Desmos, we probably could hit every point in the plane, maybe.
Maybe it's that too. But even then, if you vary C1 and C2, you're basically making, like, generating the surfaces, and those surfaces wouldn't intersect at every XY point, I don't think. Maybe they would. I don't know.
Yeah, I feel like they might. I feel like if you picked a point in the plane on your Desmos graph, you could mess with your two sliders to get two hyperbolae to go through that point, right?
Oh wait, Desmos can do 3D. Maybe we don't have to. I guess we don't have to wonder. Good luck, developer. They intersect every xy, they're the same curve. Okay, yeah, that's a nice way. So wherever they do intersect, it looks like a right angle. But yeah, if they intersect at every point, they would have to do the same thing, right? So yeah, I think it's just wherever they do happen to intersect. Okay, and then in 2.1.2, they give a real crash course on fluid dynamics. This was really... They just started doing stuff. So they talk about ideal fluid flow, which is steady, so time independent, non-viscous, so there's no friction, incompressible, so the density is constant, and irrotational, so there's no curl. And so you can express the incompressibility and no curl as equations. And they do this random change of variables. And apparently these variables have a physical meaning that they don't really explain. They call phi the velocity potential. Because if you take the derivative of it, you get the velocity, I think is where they're going with that term. Like if you take the derivative of potential energy, you get a force. And then psi is the stream function, because they show later on that it gives you the stream lines, which I think are the actual lines of flow for some reason. Revon, this is a reading group about complex analysis where we follow along a book and discuss the book and solve problems. But yeah, each of these are equal to 2 of the components of the actual velocity, which I guess is the thing that we're interested in finding. And you can take the phi and the psi and just slam them into a complex function like u and v. And then do complex stuff with it. I read through this twice, and I only sort of understand what they're doing. They take advantage of the mutually orthogonal level curves. Okay, this part I guess in the second paragraph, page 41, the second sentence, see a thing called they use the fact that level curves are orthogonal because it satisfies the Cauchy-Riemann equations to conclude that the level sets of the stream function psi follow the direction of the flow field. And I was having a hard time, but psi is the thing that's perpendicular to phi, and I thought phi was the velocity or velocity potential. So
it reminds me of what Collar Cone said a minute ago about gradient being normal to those level curves we had. Because I was thinking, oh, the curves are at right angles, but I guess their gradients are also at right. So, so it's kind of like if you turn 90 degrees, you're off one curve, you're on the other curve, kind of thing. So I guess that's what's going on here.
See you, Revon. I guess so. Then it got really weird because they started talking about something called the normal derivative, which is the gradient dotted with a unit normal vector. And I was having a hard time with this too because I thought the gradient basically follows like a tangent plane. And so if you dot it with something that's normal to the surface, wouldn't you always get 0? So I still don't know like what to think about what this actually means. So we need to relate holomorphic to vector calculus in Green's theorem. We use that to prove the main theorem of complex analysis named Cauchy integral formula.
What's this partial d phi dn?
And so that's just, I think, an abusive notation. N isn't, well, I guess it is a variable, but it's whatever the normal vector to the surface is. The actual thing you're taking the derivative of is phi, though, with the gradient. But yeah, I don't know how this would ever not be 0 if one points tangent to the surface and the other one points normal. Or maybe I'm wrong, though, the gradient points tangent. I don't know. Hey, RB.
We need somebody who knows fluid dynamics or something.
I was Googling it, said it seems to come up in PDEs in general, but I couldn't find a good like graphical representation of where everything is pointing. Yeah, I think that was like one of my bigger questions. After this, it's kind of, I think I could follow along, or just like I could like do the math without necessarily understanding why. Gradients orthogonal to the curve and is normal to something else. Maybe. Phobos, yeah, this book it pretty quickly gets into a crash course on fluid dynamics. Lubert is saying, for a point AB, there are two level curves that meet there in the case of z squared. We take the level curves x over minus y squared is a squared minus b squared, 2xy equals 2ab.
Yeah, I think that's what I was thinking.
Fair enough, Lubert. Fluid dynamics is one of the trillion things I don't know. The normal derivative seems like a more general thing, but yeah, I'm not sure. Yeah, so it does look like a regular directional derivative, just in a particular direction. I just have a hard time making sense of the direction that they're choosing. Try to get hard into fluid dynamics. Oh, nice. So yeah, I think maybe N is normal to something else, like RGPT is saying, but I'm not sure.
That sentence is hard to understand. Like there's a period, boundary is a streamline, and then there's a period. I can't really understand this sentence.
Oh, the entire sentence?
Yeah, is it like a new sentence starting with the partial d phi dn? Is that a new sentence?
Yeah, I think I mean like the fact that d phi dn equals this implies del phi points in the direction of the tangent to the boundary.
Yeah, okay.
See ya, RB. Oh, did you figure it out, RG? That'd be great, because I sure haven't. N is normal to the boundary. Phi is some other function. Wait, if phi is related to the velocity.
Oh, they're talking about boundary conditions, are they? So you got like water flowing through a pipe and they're going around they're using the surface of the pipe as like a boundary, maybe.
Yeah, stuff like that.
Okay.
So folks, in this case, phi is related to the velocity of the fluid at any point. So d phi dx is the first component of velocity, and d phi dy is the second component of velocity. And it's called the velocity potential. 41 and show full page. Hopefully that's still readable. See, boundary conditions in an ideal flow problem at a boundary can be specified by giving either vanishing conditions on the normal derivative of phi at a boundary, or by specifying that psi is constant on a boundary. Phi represents normal velocity, which vanishes on the boundary. So normal to what?
No slip, yeah.
Velocity of fluid point of contact is 0. Okay. Hey, nobody. Yeah, I know. So the section is definitely pretty difficult to follow, but they do work through some examples which can always show what to do. They do it for a simple kind of constant flow, and they also do it for flow with a cylinder blocking in the way. And that was the end of 2.1. The direction of flow is perpendicular to the surface of the pipe. Oh, okay. That makes sense. That would have to be 0. Otherwise you'd be bursting from the pipe. Okay. So maybe I'll scroll through I'll scroll through 2.2 as well. And then we can start working on some problems. So 2.2 is about multi-valued functions. We're only halfway through the stuff that I want to cover today. I chose an actual exercise involving this, but ideally I like to cover all of 2.1 and 2.2 today. It might be unrealistic, but like we are going to back up and work through some of these exercises here. See, 2.2 is just kind of a lot about multivalued functions and branch cuts. I never heard of branch points before. And how they define this is very like funky. Relations. Like, it's kind of funny because a function by definition isn't multi-valued. But yeah, not well defined. Yeah. And so they define a branch point, which built into branch cuts, by basically taking a circuit around that point and seeing if after one circuit you get to the same value. And so they make a point that with the function square root of z, you have a branch point at 0 and infinity. For the infinity part, you have to do a transformation with 1 over z, but or z equals 1 over t. But the point is, if you do a small circle around 0 for z to the 1/2, you end up with like a different value than you started with. Whereas if you did it at any other point in the complex plane besides infinity, you would get the same value. Which I had a hard time kind of seeing that second piece of any other place it does work, but I know I only sort of understood that. But once you start actually talking about functions, the idea of a branch cut started to make more sense to me, just kind of intuitively. The more formal way they seem to be doing it above It's still a little bit lost on me. Need to find the complex logarithm. This one I was able to follow this mostly better than the previous section. They do some tricky algebra in some steps. But I kind of took it as a separate piece of paper and worked through a lot of it for myself. This fails the vertical line test or radial line test. That's when you make the branch cut. Okay. Sounds good, Klex. Thank you. I'm sorry if the yard work is coming through my mic.
What'd you say? If what's coming through?
Oh,
I didn't hear it. No.
yeah, I muted myself on the stream on purpose. There's a leaf blower literally right outside my door. Yeah, I had that example in the back of my head. It feels like that analogy only goes so far, though. It feels a lot more complicated. Like, the motivation is the same, but it gets a lot more complicated with complex numbers. The last part of this 2.2, they're just kind of talking about a lot of stuff. They do get back into the fluid stuff with the z squared. But I don't know. They just kind of said that you could think of it as a transformation of the simple uniform case. Was their main point there, I think. I don't know, 2.2 I didn't have that much to say about, to be honest. It was more about like 2.1. I guess, do you want to get into some problems?
Always.
Okay. So backing up to 2.1. The Excel link, I should have posted it. It looks like I did, yeah.
I tell you, I'm getting pretty good with this iPad now.
Nice. Okay, so these are from the first section. For this one, for the sake of time, I chose just A and C for no particular reason. For the stream, I use Firefox. For like personal use, I usually use Chrome, but I wanted to use a different browser, and Firefox is what came to mind for stream. Given the real part of an analytic function of z, find the imaginary part in the function of z. So I think, what?
No, I'm just saying,
I think what they want us to do here is, since it's analytic, we can use the Cauchy-Riemann equations. I should really just have these memorized, but ux is vy. Because it's kind of interesting, like, if you know one part of an analytic function, I guess you always know the other part. Vx is minus uy.
Is there a way we can cheat here?
That'd be cool. Oh, that's going to be part of the difference. That's basically part of z cubed.
Yeah, doesn't it look like it? Yeah, that's what I want to think of too.
Oh, Slim, I literally just crop it in OBS. I don't do anything special in with the Firefox browser itself. Because I worked through number one, and they had you actually like, or I at least multiplied x plus I y out.
Well, these things here are all u.
Yes.
Okay.
And so they might do some like switcheroo if they multiply it through by I or something. How does this multiply out? I don't have to do it all again.
1, 3, 3, 1.
Well, yeah, but I don't know what has eyes or not.
Every other term. Let's see.
So if it's every other term, it will look like. Oh, but there's potentially minus. Wolfram Alpha save me.
Oh no, Wolfram.
I did it yesterday. I just can't remember what exactly goes where, and I don't feel like doing it a second time. I'm just lazy and don't want to expand it. It's my problem, RG. Okay, yeah, you're right. The eyes do alternate, but the last two terms are negative.
That sounds right.
There we go. And so we have positive 3x squared y minus y cubed. I forgot the I. That probably is what saves this. So it's probably solve for A. FSZ is going to be something like minus IZ cubed. No. No. Yes? Wait, I'm looking at the wrong terms. Never mind. There's
So here's our real ones.
yeah, we do need to multiply by I in some way, because this is the real part.
Oh, so we can
I think I
factor
had it
out
right.
an I. X squared y. Okay. Should we you know what? We could check it by these guys. I mean, if we wanted to. Let's check something here. So
Yeah, we could do it the
UX.
intended way. Yeah.
So U equals.
I think so, Slim. Colquin, I bet they could be off by a constant.
Is, Y is. So that's UX and UY. And then we want this one to be VY. Set this to VY. And we set this to negative UX. Am I doing this right? Negative VX. My handwriting. Boo. So if we integrate, this y, what do we get? Yeah, we get 3xy squared here, don't we? And if we integrate this x, we get x cubed minus 3xy squared. So if I negate this, so yeah, and doesn't this look like negative? Doesn't this look like negative?
Well, wait,
Sorry, what am
you
I doing?
integrated, so
Sorry,
these are both
yeah,
V, aren't they?
yeah, these are V. Sorry, sorry.
No worries.
So I want these to both look like V.
And so there, it's a weird thing where you get a constant of integration that could be a function, like Slim was
You get a
saying.
constant, yeah, because let's see. So I still wanted to gate this. Here we go. Okay, so I'm getting basically 3xy squared minus x cubed and maybe plus some constant if I put this together.
Right. That should.
So does that check with what we had up here?
Because that's the imaginary part. So we multiply an I through there. It does if we flip the signs as well. And that does agree with what I put, the minus I times that. I think that's good.
Nice.
Technically, color code did point out there's like a plus C type of thing that happens, but I don't know if that's that important, but they could be off by just like a constant. Yeah, I'll put it in. It's more complete, right?
Oh, I see. So the imaginary part could just have a constant?
Yeah. Either that's just a complex number. I think they both could.
It was like the number 6. Yeah. Okay. Yeah. I see.
Because it'll go away in the derivatives.
Yep. Nice. What about part
okay.
C?
That looks like something, right?
Yeah.
Something with trig or something. But we should probably just do it the old-fashioned way.
Looks like a field radiating out from the origin or something.
Oh yeah. So ux is oh my, this is it. Okay. Minus x squared plus y squared times 2x. And that's also vy. Oh, that's so annoying to integrate. I guess we're integrating in y. That could be worse.
Yeah, it'll just give us x over x squared plus y squared, won't it? Something like that.
I guess we'll work through this piece first before moving on to the next one. Squared plus y squared dy. U is x squared plus y squared. No, the 2 goes away, so minus x out front. 1 over u squared du. Okay. Then when we integrate, there's another minus sign and a 1/2. Plus a function of x. So x over 2 x squared plus y squared plus something in x.
Okay.
And then we need to find negative uy. Oh, that's a quotient rule? Bruh. Okay, low d high. Minus high d low I don't think this simplifies. It's like your parents
Oh,
knew you'd be a mathematician. Sorry, what?
this looks less pleasant.
It does. This is in physics. We would just look at a table of integrals, I feel like. I feel like there should be some type of, like, it feels like there's some type of factoring thing, but I just don't really see it. Okay, if I make x into a, what does Wolfram tell me? Because the point of this isn't to test our integration skills.
The point is always to test your integration.
It's a minus sign on top, right? Josh, I can show in a second. Really? It's y over x squared plus y squared. Oh, I guess it kind of has to be, right? I don't know why I put that parentheses there. Plus some. Oh wait, we're integrating an x here. Oh no, I did that backwards.
Yeah, something doesn't
seem
right.
I need to edit the Wolfram alpha. That's the question, Josh. Section 2.1, number 2. I'm about to click away from those, so take a screenshot or something if you want it. Part C. Yeah, I forgot we were doing this in X. No. Okay, it's minus x over a squared plus s squared. That's still really simple.
Cool.
And that matches, well, we're off by a half, aren't we?
Yeah, do I trust this 2? Let's chase this 2 that we found before. I don't like this 2.
Okay.
This one here, I'm suspicious. I didn't think it was going to show up.
Where did that show up from? It showed up from the power rule on U. We had a 2 in the original problem. It went away in the substitution. Oh, we're also off by a negative sign, aren't we? That seems like an issue. Do I not know how to integrate?
Oh, damn it. I think it's this, isn't it? Right here. Right here. Maybe that's not supposed to be. Yeah, this 2.
Well, that was from doing the power rule on the U. Oh wait, did I did that wrong, didn't I? Oh my god, it's n plus. Oh, yep, you're right. Okay, so that I still have a negative sign on the other one.
Well, there's a negative here. Oh, but we lost a negative here, didn't we?
Yeah.
What about this negative here when you put these negatives here? Did that negative go? Is it supposed to be
I just
here?
forgot it. Okay, thank you.
Okay.
Okay, I think we're all fixed then.
Cool.
And so I think our functions aren't anything at all besides a constant. So what we
'cause
have,
these guys match up.
right? So the real part was y over y squared plus y. X squared plus y squared plus I x over x squared plus y squared plus some constant. This looks like something though.
So we got y plus ix.
Yeah, is that like negative z or something? Not exactly.
X plus iy, y plus ix. It's like reflected in the.
I guess it's not quite like the perpendicular, if I'm thinking as a vector. It's a reflection across y equals x.
Yeah, that's what I'm thinking. It's like you got a point here and it gets reflected to there. You got like this triangle becomes that triangle.
I wonder if it's like 1 over z or something then. I'm just kind of spitballing. Do they actually ask us to get it in z? Oh yeah, they do.
Oh, wait a second. If you multiply that by I, you get.
Oh, it's just minus I times z. That's way.
Factor out an I.
Factor
it's
out
I times
the
z conjugate, isn't it? I think that's what it is. It's I times z conjugate, maybe.
I like that.
Yeah, because look, z conjugate is going to land here. There we go.
We need to divide by like the magnitude of z or something.
And then if you rotate, yeah. So this is z. This is like z bar.
Conjugate over.
There's iz. Sorry, I'm making a mess.
No, you're good. I guess like that.
Yeah, nice. Is there a nicer way to write it, I wonder?
You think it is 1 over z, which is the same as z over z bar squared? Or bar z? 1 over x plus iy. Wait, if we rationalize it, is it the same? No, we conjugate. Oh, interesting. Yeah, x minus iy over... And so and you conjugate. Okay, yeah, this is the same. Oh, because z squared is z bar z. That's way more direct than what I did. Okay. What am I doing? That zooms?
So it's I over z, right? Yeah, that worked.
I over z. Oh, okay, yeah.
I want to say this I stays here.
Yeah, it does. Okay, so let's write this. Let me just get this better organized. Oh no, not that. I keep hitting the wrong thing. Okay, just to have things lined up better. So iz bar over z bar. And then the z bars cancel is the point. Okay, nice.
Nice.
Okay, so that's it for number 2. Let's look at 3, I chose A, B, and C. I don't think I put very much thought into it. Determine whether the following functions are analytic. Discuss whether they have singular points or if they are entire. Well, what do we know about tangent?
Sine over cosine, I guess.
Yes. They do provide the complex definition somewhere in chapter 1.
Now, I did read chapter 1.
Yeah. Oh, I guess, yes, someone's maybe giving the more direct thing, which is just using the sine over cosine thing. And we just need to hold so that cosine of z isn't 0. They do say that somewhere in chapter 2 that I think you usually only have to check for things like denominator being 0 or like breaking the rules like that. So we need to solve the equation cosine of z is 0. I feel like we've talked about this before. Like we were debating if there could be imaginary solutions for this, and there weren't. Oh, the quotient rule, true. Yeah. Like, because we know sine and cosine are analytic, the quotient rule means that tangent should also be analytic as long as the denominator isn't 0. I'm trying to remember the logic for whether cosine of z equals 0 has any imaginary solutions. I guess we could go to the exponential definition. Which God knows I don't have that memorized. Just multiply each side by 2e to the iz, I guess. Oh, well, yeah, this should just give us, pi over 2, right? In 3 pi over 2. Hey, Suna. But yeah, these are just strictly real. Wait, for -1. It's just pi over 2. That's going well. How about you? Wait, what do I expect cosine? Cosine is 0 at pi over 2 and at 3 pi over 2.
Yeah, that feels good.
Why does 3 pi over 2 work in this equation though? That's what I'm getting confused on.
E to the 3 pi 1 2
okay, yeah,
3.
it does.
Yeah,
okay. Okay, so that's where it's not analytic at all of those. Oh yeah, I changed my name, Suna. For a lot of reasons, but Yeah. And now dot exclamation point.
So what does that mean? We've got a function tangent z, and it's singular at all these points you just found, right?
Yes. So I guess it's not entire. Because
So what
entire
does that
means
mean?
there's no
It's
singular.
analytic everywhere except at those points?
I believe so, yeah.
Okay.
Okay. Thank you, Suna. Okay, so for part B, e to the sine z.
And if your k is an integer, you don't need the second line there, right? The first one will do.
Oh. It sure will. Hey, Anrid. So for e to the sine z, they were doing like a rewriting trick. Wait, does that even apply here? Never mind. I don't know what I remember. They were doing tricks with like logarithms before. I don't remember if it's here though.
I bet you we could argue that composition of entire functions give us an entire function, maybe.
Oh, yes.
I'm pretty sure
I think they
E
say
is
that
entire.
somewhere. Yeah, E is definitely entire, and sine is just a linear combination of e's.
Oh yeah, so we're probably good.
An entire function, e to the z is entire, as is sine z and cosine z. So is z to the n for integer n greater than 0.
Chain rule, yeah, chain rule. Yeah, so we know how to differentiate this guy.
Okay.
I think, right? Don't we? If we had to differentiate, I know we don't have to, but if we had to, I think we
I
could.
think it's the same thing. It should just be that.
Yeah.
Okay.
Now, what if we wanted to do this a different way? What if we wanted to use Cauchy-Riemann equations on it? That would be awful, wouldn't it?
Yeah, it'll be like e to the e.
All right, forget that. I was just wondering about it.
That's an exercise for the reader.
Yep.
I guess by the same logic here, for part C, like we just need z, like z equals 1 is singular.
Okay.
I don't think there's anywhere else where it'll be singular. Oh, do we have to worry about infinity? One over z squared only has z equals 0 as a singular point. I don't think we have to worry about infinity. I say I hope we don't. No, infinity should be fine. Because it's going to be like e to the 0, and that's fine.
Yeah.
Okay. Okay, I'll bring in the next one then. I think this was the last one I had for 2.1, and this was I want to get some type of fluid one in here. C is not entire because it has a singular point. Because entire is the entire complex plane, right? And the entire finite plane. Okay, so even if infinity was a problem, it would still be entire. So not entire, because z equals 1. Corresponding velocity, potential, strain function, and velocity field.
Oh, wait a sec. Slim is telling us
Is z
maybe
equals 1 a problem? Oh.
So as z approaches 1, what does that mean? The exponent goes to infinity, and we're looking at like e to the infinity.
Oh.
So is that not a problem?
Huh.
Well, let's try and differentiate it, right? What happens if we differentiate it?
I think we still get a denominator. That would cause us issues. Slim does think it's a problem.
I keep.
I feel like it's I think it's still a problem. Differentiation shows that it's an issue. Okay. It's not defined at z equals 1, not continuous, not differentiable, singular. Okay. Yeah, that's what I had in my head. Like, we can't even begin to define it as z equals 1, as far as I know, unless we can rewrite it in some way, so I can't imagine we'd be differentiable at a point where it's not defined. Okay, unless there's anything else on that, I'm going to go back to number 6 here. So omega of z is equal to phi plus I psi, and phi is the velocity potential they're asking us to calculate. C is the stream function. Psi. I've heard it pronounced both psi and c, I think.
Yeah, I always heard psi.
Okay.
Well, doesn't that look like the little weapons that Donatello uses or whatever? Which Ninja Turtle had the psi?
I don't remember. I know the thing you're talking about, though.
Yeah, it's like a little sword catcher, isn't it? Like the guy tries to hit you with the sword and it gets stuck in the thing and you break his sword off.
Yeah, the dagger with the prongs.
The dagger with the prongs, yeah.
Elektra in the Daredevil Netflix show had those too.
Oh, okay.
Yeah, I always thought of a trident like Poseidon or something, but that's a funny one too. What would the velocity field? I guess we would integrate one of these bad boys to find the velocity field. Essays? I'd never heard the name of it then.
Size.
Size?
I don't know how to spell it.
Huh.
I thought actually the plural was psi. One psi, two psi, but I have no idea. I'm just kind of guessing. If
I
I was gonna
definitely don't know.
spell it, I would say SAI, but I'm just kind of guessing.
Okay.
Okay, I got to Google it. Teenage.
In the meantime, I'm gonna calculate 1 over z.
The psi, SAI. Yeah, Raphael's weapon. That's who had it.
Okay. Can I invert this in my head? It's just x over x squared plus y squared minus y over x squared plus y squared. So then our phi is just the real part. This might be a radial flow like we were talking about before. So I think for the velocity field, we need to use the fact that v1 is d phi dx.
Is that last line going to be plus instead of minus?
It sure is. Raphael's opened the best Teenage Mutant Ninja Turtle. I'm gonna be honest, I've actually never watched it.
I gotta say, I think Raphael was my favorite too.
Really? Huh.
Oh, I used to love that show. It's one of the only cartoons I used to watch all the time.
That's funny. I
Actually,
feel like I missed out.
it was when I was in college in the 90s. I used to I guess I used to love that show.
I guess we got a quotient rule for taking the derivative. I don't know why I thought we'd have to integrate. It's a derivative, right? Lodi high. But yeah, people, I forget when, but people definitely call me Donatello in reference to the Teenage Mutant Ninja Turtles, and I was kind of to like play along, like, yeah, haha. Because I've seen like little clips and things, but I never actually watched it. Okay, here I absorbed the minus sign into the numerator. And I think that's okay. He was a troubled dark one character. Comps, I think he goes mad at some point. The comps are darker, wow. Interesting. Okay, so for the derivative in y, there's no quotient rule. We can get rid of the minus sign. 2xy over x squared plus y squared squared. So this is like an inverse square, and there's a hyperbolus happening. So what? The velocity field is. Oh, I bet there's a clean way of writing this with hyperbolic functions or like Cauchy cinch or something. Maybe not. I don't know. Can we get Desmos to draw us a vector field? I guess we're supposed to draw it ourselves. I think the book is asking us to do that. But it's always something inverse square. Sketch the stream function. Oh, they want to
Yeah,
okay.
the
Not the
side.
velocity. And I assume
Isn't
we're
it
doing these
just
as level curves. Sorry, what?
okay, level curves?
I would think so. I think that's what they were doing. That's what their figures were for the actual flow.
Yeah, yep.
I think so. Yeah. Yeah, it's psi equal constant. Okay. So, and I think once we get the trend of it, we can just kind of fill in the blanks.
Are they going to be circles?
Ooh, maybe. If we just have, say, 1 equals k over 2 pi y over x squared plus y squared. How does this? Actually, no, we could just keep that as a constant. That's probably better.
Yeah. And we could call this B maybe.
Oh yeah, just to simplify the writing. Okay.
I mean, it's got to be a circle, doesn't it? Doesn't this just shift it somehow? Shifts the...
It's equal to 0 though. I guess we're going to complete the square.
Yeah, well, when we complete the square there, we'll get something here.
Let's see what that something is. B over 2. Oh, there's a minus sign in here. Well, it's squared. Is this the thing we do plus and minus of?
Maybe.
I was confused with completing the square.
Yeah, because that would give us an over A here, wouldn't it? Okay. All right, this might work. Is it just A times Y? Yeah, A times Y minus B over 2A. Whole thing squared. Does that work?
We need to fact check this.
Yeah, let's just check it.
Yeah, okay.
It seems all right. Equals B over 2A. Oh.
A times B over 2AY. A times, oh, yeah, okay. 2AY. The sign, we're taking
is there
this
something
one.
wrong with this A not hitting this one maybe or something?
Oh, I didn't multiply the A by that one, did I? Oh, man. Dude, I hate completing the square.
Let's put an extra A here. If we put an A here and an A here, we're good, aren't we? Does that fix it?
It should match if we do that.
One of these is a mover again.
Japanese. This is excalidraw.com. Also, hey, MMD.
Like that.
Hey, Poison Mouse. Oh, whoa. You were applying a transformation.
Yeah, I know I am. I'm not trying to. Good grief. Just redo it.
I guess if we stick the A in front, that should save it.
I think it works.
I don't know why complex analysis is easier than computing the square with a leading coefficient, but I think it is. So how does this factor then? Wait, yeah, this is just good as it is.
Over 4a, right?
Yeah, okay, that's what we get. Okay, yeah, I agree with this. Oh my gosh, and we divide the A to the other side as well.
Oh, yeah. Probably should have just done that in the first place, right?
Well, it would have gone into the 0 though, right? I don't know, that's, well... No, no, never mind, it wouldn't. I don't know. And then B is K over 2 pi.
But our A was any number we wanted, right?
Yeah, that was the level curve. Okay. So what does... We used to have circles of various centers and radii, right? This is almost like you're skipping a rock down a pond. That's what I'm guessing. But that doesn't make sense as a flow, right? I use a tablet, just a cheap Huion thing. I don't use Poison Mouse. No. So K is a constant, A is the thing that we would vary for the level curves. Welcome in, Lega Royale. No screen, no. The tablet, it's...
So what do they look like? So they're always circles
something.
that go through the origin, right?
I think they're mutually tangent circles.
Yeah, and they all go through the origin, but they get bigger as you move up or down. Yeah. I'll tell you what, go over here. You need more real estate, I think.
Yeah, like I'm not sure what I'm going to draw here.
Aren't they going to be like this, like a circle like this and a circle like
I guess
this and a circle
like
yeah,
they will be crawling up the y-axis.
Oh, that last one was crummy.
Oh, interesting.
Yeah. And then also down here, maybe?
It's a circle, Poison Mouse. Yeah, because we can always make A negative. So wait, what's the small values of A are the big circles.
Well, we could have made our A 1 over A. But whatever. Yeah.
Oh. Yeah. Okay, fine.
I guess we could have. I don't know what this picture means. What's this telling us?
Yeah, I like to orient this somehow. Yeah, like these things are really nice. It didn't take long for me to get used to mine. The value k is called the strength of the doublet. Doublet? I don't know. Oh, it's almost like, I don't know if they're necessarily getting, I guess they wouldn't be getting stronger. It's not a whirlpool though. It's just like, I don't know. It's almost like a whirlpool, but you go around in circles. You don't get sucked in, is what I'm imagining.
I have no idea what this is telling us. Maybe it's wrong.
It's possible.
See also problem 4 of section 2.3. We didn't really get that far, right?
No. Okay. 2.3 is one that I think we would. It's a starred one as well.
Okay. A limiting procedure of two elementary flows referred to as a source and a sink.
We could Google doublet flow.
Yeah.
Oh, I see a familiar picture. It looks like we got the picture right.
Yeah, get out of here. Nice.
Well, we didn't orient it, I guess. I don't know how we orient it, to be honest. We have to get in polar. Oh, interesting. Pokeways mouse.
The source and the sink approach each other at the same time.
Oh, and you could draw the orthogonal circles as well for phi. So yeah, maybe we should have gone to polar. Sorry, what?
What are these two circles again? One of them's telling us which way the water's flowing, and the other one's telling us like the potential or something of the water at that point.
Yeah, something related to the velocity or something. The velocity potential. Yeah. I don't quite know how to read that one though.
So it is like a whole bunch of whirlpools all going through the origin.
Yeah, I'm not sure that it's necessarily like sucking in. Maybe it is.
Do you want to copy paste that picture over, and I'll erase my crummy one?
Sure.
Yeah, let's do that because I don't like the one I drew here. Get a nice one.
Yeah, Mouse, this book is doing like a crash course in fluid dynamics.
But you came up with the, when you found the level curves, it made me think of those circles, so we were right on it.
Yeah.
What about this velocity field? What is that telling us? Is that telling us like little velocity vectors on those blue circles as we go around? Like if I picked an XY here and plugged in XY, maybe that right there would be this velocity vector, maybe.
Well, the weird thing is that this was after a derivative. Is the velocity like phi is the like that we had to do a derivative to find that velocity vector in of phi and psi.
Yeah.
Mouse is saying to check the link below the one that I clicked on.
Poison Mouse says the whole world's done.
Yeah.
I know.
We got you.
Fine. I'm still getting better with this iPad. I'll tell you, I did some circles last night. I was watching Dr. Gold's stream, and I was doing some geometry on here. And it's easier when you're not on, when nobody's watching. So yeah.
A source
Yeah,
and a
this student,
sink.
this oh, there it is.
Distance approaching 0. A student was what?
Yeah, the student at my work came in the tutoring center the other day, and she showed me how to put OneNote on this iPad. So now I got that Microsoft OneNote on here, and it's pretty cool.
Yeah, I know Penn Center, like that's his main thing for math. It seems nice.
Just give me a couple weeks. I'm gonna be like a wizard on here.
You'll have everything you need to do your own math stream.
Yeah.
Okay,
everything except time. Oh, my phone's ringing. Sorry. How do I mute myself?
In Discord, there's like the little microphone icon, lower left, right next to your name.
Sorry.
You're good. Okay. While he's doing that, I'm gonna. We got more time for 2.3.
Oh, I found out how to mute myself just in time to not pick up the phone.
Oh no, I was gonna like deafen if I heard you speaking, so you wouldn't have come through. But do you want to call him back? I don't mind if you take a break.
No, I have no idea what it was.
Oh, okay. Oh, so someone has a question for you though, Fembox. Do you see it?
Slim. I watched that. You know what? I watched the first episode of Rake on some kind of free streaming service, but I wanted to watch more. But it's like a 45-minute show. There must have been 20 minutes of ads, and I'm like, no way, I can't do it. No, I can't. I can't sit through that many ads, even for a good show. I can't do it. So I'll have to find a way to watch it without ads.
I forget. Did you grow up there or just like visit a lot?
No, I was born in the U.S. and I went to high school in the U.S. But then when I was 16, I went to Australia and I finished high school over there and I did college over there.
Oh, cool.
And I lived over there for 20 years. So when I came back to the U.S. in like 2001, 2002, whatever it was, I had a pretty good Australian accent.
Wow,
but now it's pretty much gone.
Yeah, I don't hear it. You want to meet kangaroos?
No, my dad told me I sound very, very American. I said, well, yeah, that's because I am.
That'll do it.
Yep.
Okay.
It was pretty cool. It was pretty cool. I mean, I like the Australian accent. I really like it. Cool.
Yeah, they have a certain like inflection too. Not necessarily just the way they talk, but like, I don't know. It's kind of hard to describe, but it feels a little like unique.
Yeah, you can definitely pick. It stands out. I mean, you can pick it right away.
Yeah.
A lot of people confuse Australian accents with British accents, but not me. I know an Aussie right away when I hear one.
Yeah, I still can confuse them, but I'm just like not that well practiced. I can definitely hear the difference once I know. They do have cool lingo, yeah. You taught me hoon for like the people with like the wild cars.
There was a hoon going down your street. Yep.
Yeah. Obi says, my cousins are U.S. citizens, born in Ireland, lived for several formative years in El Salvador, moved to Australia for several years before moving back. There's a real odd mix of accents. I bet. That sounds like a cool life, though.
It's funny when you have that kind of mixed accent, because it doesn't matter where you go, you sound out of place. It's funny.
I bet.
Like when There was a point where I'd go back to Australia. Everybody say you sound American. I'd come over here. Everybody say you sound Australian, and it's like, well, I can't win. No.
Yeah. See ya, Omer. Foreign service kids. Oh, okay. Like I said, down towards the bottom, I brought in the first of questions from 2.2.
Yeah. Yep. Got it. Branch
Canadian.
points and branch cuts
With the round vowels. Interesting. So I was just thinking A and B for this one. Oh God. What? So for A, surely Z equals 1 is going to be a branch point. So the way they were talking about branch points was kind of interesting.
Yeah. I didn't catch that. You said they were taking a little circle or something.
Yeah, so they started by looking at the function.
But what are they doing as they go around this little circle?
Square root of Z.
I mean, it's not an integral, right? We're not up to that yet.
Just looking at the values of the function. So like basically, if does the value when the argument is 0 equal the value when the argument is 2 pi of the function? Ben, hope you're doing well, dude. And that I felled trees. Wait, what? Yorkshire. Oh yeah, true. So you basically you find these branch points by figuring out when the function value doesn't match after completing a small circuit around the point. And then you connect those two branch points to make a cut, which felt very odd, but you can have branch points at infinity, which I would wonder what would it look like if one of them isn't finite or isn't infinite.
So does that mean for part A, we want to think of Z as being like 1 plus some little delta times e to the I theta, maybe?
Something like we might want to look at polar.
Yeah, that's what I'm saying. Like an r e to the I theta, where r is really small,
Yeah.
and you're just doing a little circle around the point near the point 1.
Yeah, they were doing stuff like that. I remember now. Slim, they just did a transformation like Z equals 1 over T and then did T equals 0. So I guess it's kind of like a stereographic thing. Papadoria, same mic, but I brought it way closer to my mouth. So I hope this is an improvement.
You're definitely, you haven't cut off at all today, so it's nice.
Oh, good. So I think let's maybe put this thing in polar. Oh my god, it's Zach. E to the 2I pi. Okay. That's how I'm gonna remember what one is in complex polar form now. Ugh. We want these to be like. Maybe I should have done this differently. We want to make it one thing, right? You have me on surround sound, Papadoria. Okay, maybe I need to do it as like x plus or x minus 1 plus iy and then translate that. Sorry, Lucas. Hopefully you get through them soon. I'm getting confused on this now.
Uh-huh.
I was going to translate this into polar, but I feel like it's just going to look weird. Like I'm not going to have a theta. I mean, I'm not sure you have to have how to. I just wanted to put this thing somehow into polar coordinates.
Could you set it equal to W, maybe? Like say W. What have I done? I got a keyboard on the screen here. Again, what the heck?
To make it easier to do a circle around a point.
I'm just trying something. I'm thinking of this. So square it and flip it.
This could be something.
It doesn't do anything, does it?
I don't know what to do with it, but there might be might be something. I don't know.
No, I don't like that idea.
So we could definitely consider like just 1 over z to the 1/2. And then just know that whatever result we get from here will be shifted for z minus 1.
Yeah, that's what I was thinking. That's why I was saying like let z equal 1 plus, 1 plus some little thing.
Oh, because I think they were doing stuff like that. Yeah.
Because don't you want to do a little circle around a 1 like this?
Yeah. They're doing something exactly like that. They would be like consider z equals 1 plus some re to thy theta where r is very small. I think that's
how that's why I was calling it.
Okay.
I was calling it delta.
And so we would end up with 1 over r to the 1/2 e to the I theta over 2. And so we would show here that 1 is a branch point by observing that there's a difference between theta equals 0 and theta equals 2 pi.
Oh yeah, I got you now because it's theta over 2.
Yeah, it's the over 2 that like makes it weird. Hey Slayer.
Yeah.
And so for whatever reason this doesn't happen with any other point. I should maybe try to do that at some point though. Sorry, what?
I'm just thinking of what we do next. Discuss possible branch cuts for the function. So
I imagine there's another one at infinity if we did the proper substitution.
Possible branch cut.
And so the cut will be... How should this look?
Because I'm just remembering complex log, and wasn't the branch cut for complex log on the negative real axis? Isn't that where they usually put it?
Yeah, usually. This book, I think, does it... The book kind of goes both ways, but they often put it on the positive real axis. But either works.
So does that mean you could really put it anywhere? I mean, you could make any sort of... Like, could we put a branch cut going north, like going all the way out to infinity that way?
I think it has to have the right shape. It's not... This one will be a line, but I don't think it has to be a line. Or I think there's something weird. Like there's some... There can be weird branch cuts, they were saying.
Okay. Yeah, my bad. I really should have read that. I thought I'd read it, but then when we were about to start, I'm like, wait a second, I haven't read this.
It's okay. I wish I understood this part better, I guess. I feel like I understood it when I read it, but now when I'm actually trying to do something, I'm realizing it's not so simple. Um, like I think our branch cut is still going to be kind of our regular.
I want to say we could just take the positive real axis from 1 out to infinity. I mean, I feel like that would work.
Yeah, although I'm kind of confused why, like, oh well, I guess I'm kind of confused, like what that actually, like, what about that part of the positive real axis between 0 and 1? I mentioned, like, you're saying what the answer, like, that answer is right. It just feels like a weird branch cut, I guess.
Oh, between 0 and 1?
Yeah, or like, I'm just wondering what happens with that little bit. I guess because it's translated, it's fine. Like, it doesn't actually,
Yeah.
it's just not a branch cut that I'm used to seeing, I guess.
Yeah, I know. Me either, but I just feel like that's probably how it would work.
Yeah, if I had to put money down, I'm pretty sure that's what it would be. It just feels weird because I'm used to thinking of the branch cut as an entire like axis. I think it doesn't have to be, is what the book is saying, but I've only seen like basic things.
You could probably go left as well and come down this way.
Yeah. Mulek, yeah, I could, but not right now. Maybe like 10 or 20 minutes. Yeah, they're saying discuss possible branch cuts for the following functions. So like I think they're more asking like what branch cuts are, like what branch cuts make sense.
Can you take some like? Could you take a branch cut to be like some sine wave coming out this? Would that work?
I mean, I 2.3 is a starred one that we would skip, but that's where they do the weird branch cuts. And I'm kind of interested to see what's up with this section.
Yeah, I'm gonna have to read it.
They're doing branch cuts like on a finite interval. It's kind of weird. I don't know what that really means, to be honest. Oh my god. I don't even know what's happening. There's just some crazy looking figures.
I remember that one that you're looking at there. That's the complex log, isn't
With
it?
the
I remember
spiral?
if you spin around once, you go up one level like a parking garage or whatever.
2.3.6. Yep, that's for logs. Yeah, I guess it's just the axes that were confusing me, but the complex number is like the third axis, I guess, like the z-axis. That's what they're doing here. Oh, I guess that's why they're talking about branch points being a circle having a different value. Okay. Yeah, I don't know. I might have to go and read 2.3 anyway. But so we're saying our branch cut for number 1 is, or one possible branch cut is the real part of z is greater than 1. That would make sense. But you probably do any rotation around 1 that goes off to infinity. Or something like that.
Is it the real part of z or is it just the?
That's like the expression for the branch cut. So like
it's just part of the axis, right?
that ray. Yeah, you're right. I that is a plane that I said, right? What the heck? Some key got pressed and I don't know what. Okay. The semi-axis real part of z greater than 0 is referred to as a branch. So, ugh. I don't know what a good expression is for like that ray starting from 1 going out to infinity.
We just write the set of all a0, a greater than 1.
I guess that works, yeah. Okay, and then imaginary part of, oh yeah, we could do a double conditional, like real part of z greater than 1 and imaginary part equals 0.
Yeah, there we go, something like that.
I'll just like write it down there. Okay, so what about B? Z plus 1 minus 2i to the 1/4. So if we had, so the book talked a lot about z to the 1/2. Yeah. That's where they made a branch cut for the entire like positive real axis. I wonder if we're gonna have to like cut that in half somehow.
Yeah. Are we gonna need 2 cuts now? Because we're taking a 4th root. When you take a square root, you get 2 answers, don't you? When you take a 4th root, you can get 4 answers.
Yeah.
So we have to like narrow it down to 1. So how the heck do you do that?
Yeah, I guess we want to talk
because if
about,
you go around a circle, it'll jump. Oh.
The discontinuity happens after you go around 1 time. That would feel lame, but maybe that's actually true. What the way the book is doing it, they are, yeah.
Yeah, I spent today reading, because it's really quiet in the summer at work, so I spent today reading some of that visual complex analysis book. I'm only in the first chapter, but he does some cool stuff.
Yeah, that would have been my first choice to read if there was more, or if the class wasn't using this book specifically. It seems like a good book.
I was reading the part of the first chapter. He's talking about roots of unity.
Mm-hmm.
And he's talking about looking at it all geometrically, so it's kind of cool. He does lots of pictures. So this one here, the branch point is that 1 minus
1 minus 2i.
Minus 1 plus 2i, is it? Oh, wait.
Oh,
Yeah, let's put a
you need
minus
to
1
do...
plus 2i. Yeah. Because you
Yeah, because that
want
gives
to
you
think of
0
this as,
inside. Right.
it's like what am I doing?
Yeah, fair.
So it's like we're taking the distance from z to that negative 1 plus 2i. And that gives us a complex number. And then we're taking the fourth root of that complex number.
Well, I think for the sake of the branch cut, we don't need the fourth root of it.
Well, no, I'm just talking about what the function's trying to do.
Oh, okay.
That's what the function's trying to do. It's taking the fourth root. So that means if we plug in a given z, right, we find 4 points on a circle. A circle with center minus 1 plus 2i and radius, whatever the distance from z to that point is. So something like this. So if this was let's say this was my z, right? And this is minus 1 plus 2i. The fourth root.
So I feel like the branch cut that might seems natural is like that branch, with everything with the same argument.
Something like that. I don't know. I feel like because it's going to give us four possible answers. That means we have to kind of split the plane up into 4 parts now, right? No, it doesn't mean that, because last time we didn't really split the plane up into 2 parts. We just like cut it in one line, one ray.
Yeah.
Did we have to cut 2 rays this time? I'm confused.
That's what I thought. Like we'd have to take half a plane worth of points. But
yeah, maybe.
I don't know. Some kind of made a good point where like you still just do the one complete circle and find a different value. I don't know. I'm kind of confused. It doesn't feel very natural to, or I feel like it should be harder than it is, maybe.
The whole idea is erase a part of the plane so you don't have the discontinuity issue. I think it's the same. The first discontinuity happens after you go around 1 time. Just erasing a ray from the branch point should be enough. Really, just 1? It wouldn't matter if I'm doing a square root or a 4th root or a 10th root. It wouldn't matter. Maybe. Hamiltonian says just 1 cut. Okay.
Oh, yeah.
I'm going to agree with majority rules here.
Maybe it's not, you get your first discontinuity after the first complete circle. You get other kind of distinct discontinuities after the first circle, But I think you can still do that one full circle with no discontinuities until you complete it. Maybe that's
You know
why.
what? Yeah, you know what? I think you guys are right. I think you guys are all right. Yeah, and Don, you've got it here, haven't you? It's like it's the because when you because you get theta over 4, don't you? So you'd have to so if you went up by just pi, for example, instead of 2 pi. I don't know. I'm gonna have to think about it.
Yeah, I think you should find if you. Cause I was doing that half circle thing too, and I think, like, I don't know, like, I don't think there's anything to compare it with, or like, maybe that's a bad way of thinking about it, but like, there doesn't seem to be much potential to compare with until you get to 2 pi. So, I don't know. The way that I would say is like, any imaginary number with the same argument as -1 plus 2i, and I guess like a real part is less than -1, I think would be sufficient to define that array. Okay. I guess we're a little bit past the 2-hour mark. I had numbers 4 and 7 chosen as my only other ones for 2.2. If you don't mind, because I would like to be done with 2.2. We can,
Okay.
if you have time, we can go for number 4 as well.
Sure.
Okay, and then we can just like call that good. So I don't think 4 is that big of a problem. So they talked a lot about, or they defined log and talked a lot about it in 2.2. And so they're talking about, I assume this identity is fine if you do the principal value for the log, but it's dangerous for the multi-valued version of log. Alpha is a real number. So I assume we want to start off the same way as usual for these. It's going to annoy me if these aren't in the right order. Then we get log r to the alpha plus log e to the alpha I theta Yeah, we do need the plus 2 k pi. I was just wondering where to put that in. I guess we could do it from the start. And also whether the alpha should be inside the parentheses or outside, but I don't think we want parentheses. So these are real numbers, so that's a regular log. So that identity is fine there. Then we get alpha I theta plus 2k pi. And so the important thing here, I think, is that the alpha is not multiplied by the 2k pi. Because that's what we would expect for alpha log z. Thank you, I. And so yeah, it's the 2k pi I that causes problems here.
Oh, I'm making a mistake here.
Oh, so yeah, I was. Were you putting parentheses with the theta?
I was trying to put parentheses in there, but I don't think that's right. But
I
we
was
need
wondering about
something
this
up there,
too.
don't we? Because the alpha's got to hit the 2k pi as well, right? I mean,
If it does, then my logic fails, but maybe I did it wrong.
because you're not just taking, because the alpha hits the whole exponent here. Oh, no, wait, maybe that's the whole idea here. Maybe that's the reason that they are different multi-valued functions.
Yeah, because
Okay, sorry, Slim. Yep. Okay, Slim agrees.
z to
Slim's
the
on
alpha.
track with you.
Yeah, because you can just like think of alpha I theta as the entire final angle and then add 2k
And
pi.
then add the 2k pi. Yeah, sorry.
No worries. I had to go through that same exact thing in my head, so.
Yeah, because I was trying to put some sneaky parentheses in there, and I looked at it. I'm like, I'm screwing this up. Yep.
Alpha equals 0, for example. Oh yeah, if there were parentheses.
Let's find a counterexample. So alpha equals 0. Or is maybe Hamiltonian just saying it was my mistake because of the alpha equals 0?
I don't know.
I want to see if.
I guess there's a point where if we did take k equals 0, the identity is always true. It was a counterexample. Okay.
Oh, is that good because log of 1? Wait a second now.
I'm phrasing this terribly.
Oh, log of 1. Oh, okay.
A counterexample to the other thing with the parentheses. I'm not sure it would make a difference there. I don't know though. Oh, yeah, so Hamiltonian dynamics was talking about the parentheses issue. But yeah, I don't think that causes an issue as far as I can tell.
So what's a concrete example where we could come up with two different sets that were different here? I don't know if alpha is 0 would work with it because I feel like that's just 0 for both cases. Because is the log of one
Well,
still 0 if it's a complex logarithm, or are there plus or minus 2 pi I or something on there? Multiples of 2 pi I. According to what you got here, it works, right? Because look, yeah, right there. So this alpha 0, but we still got this 2k pi I. So we could have an infinite number of 2 pi multiples of I.
yeah.
Okay, good. Then we're done. That one's done.
Yeah. And then over here, we would just get 0. So
Yeah. Do you mind if we look back at the last one we just did for a second?
oh, sure.
Because I want to see if I can understand what you said at the end, which was, I think this thing you wrote here was the branch cut, right? Is that what the proposed branch cut was?
Yeah.
So you're saying Z is like the argument of minus 1 plus 2 pi plus 2I. So it's going at that angle. So you were saying we could like go up this way, maybe.
Yeah, just like continue the line between -1 plus 2i and the origin is what I was going for.
Okay, gotcha. Okay. Could we come out again? Could we come out through that point and just go in any direction, like towards infinity, radially outwards from it?
I assume we could, yeah.
Okay, cool.
Hamilton dynamics staying the same. See, I know I weirded out by how you actually do calculations with this, but
So what is a branch cut? If I want to think of a branch cut, it's kind of like, when you do a function of the complex plane, you're like twisting it or something, right? And if you, I don't know. Let me not even talk about it. I'm going to confuse myself.
it's a way of making a function single valued and well defined rather than multiple values for one input. But the geometry of this is really confusing to me.
Yeah, I used to have this complex logarithm in my head pretty well. I know if you input, yeah, right. So if you input some number Z, and then if you take that Z and you add 2 pi I to it, it's kind of like you've gone around the circle once. And what it does to your logarithm function, it kind of moves you up one level in the parking garage or something. That's the way I remember it.
Yeah, that was that spiral thing we were just
that
looking
spiral thing. Okay. So let's think about that parking garage, right? You got the infinite series of spirals there that you got on the screen. Yeah. So what if we came along and cut along the positive x-axis, right? Or whatever. If we take one radial cut out from the z-axis, but you sort of have to imagine you're cutting it like you're cutting it infinitely along each one of those levels, right? And then you collapse them all down and they just turn into a single level. Maybe that's what it's doing.
Oh, that's a neat way of saying it. Yeah.
Maybe that's kind of what this branch cut does.
Oh, I like that. Like, yeah.
Yeah, or just putting up concrete walls in the parking garage. So whatever level you're on, you can only go around once before you hit a wall, and you're stuck on one single level. So you can't have multiple. Yeah.
Yeah, and interesting.
So did you want to do one more, or are we good?
I mean, that was one where I was thinking of. The only other one I had queued up for 2.2 was another fluid one. If you want to, we can do
fluid
it.
One.
But if you want to leave it there, I don't mind just saying that's it. Either way, I'm going to do the question probably, so it's up to you if you want to be there.
Yeah, you know what? Everybody's probably sick of me, so I'm going to bail anyway.
Okay.
And my iPad's running out of charge, so I'll leave you to it.
Yeah. No worries. Uh,
All right. Thanks, Don.
thank you for being here. Talk to you later.
Yep. See you soon.
Yep. Okay. Nice. Um, let me change around my title and category. Or not category. I'm used to doing that for the physics thing. I didn't change the YouTube stuff though. Complex is fun. I like it way more than real analysis. Much more I mean real analysis is fairly geometric, but there's some annoyingly non-geometric parts. Oh, that's the wrong thumbnail. Which is ironic that I hate most geometry problems I actually see, but I love a visual explanation. Okay. Let's write our customary announcement. Okay, so I didn't talk to you about it, Fembox. My plan was to go through the rest of chapter 2 that was unstarred for next week. So 2.4, 2.5, 2.6 through 2.6.1. Oh man, it's another like 20 pages. I don't know if that's that'll be kind of a lot if you didn't already read through the first two, but my favorite follower of them all, I'm going to do the annoying parent thing and saying, I love you all equally. We all know it's a lie, but sounds doable. All right. I don't know. Yeah, I was able to get through these 20 pages. I think it's like 25 or something in total. In a week. Also, hi Zach. I hope you're doing well. Thank you for offering help to Lucas as well. By the way, I don't know if he took you up on that, but either way, I appreciate you extending the offer. Yeah, it's slim, right? Complex about nice functions, whereas real analysis about grim ones. That's a funny way of putting it. That's really true, though. Okay. I did color cone. We've been talking about some fun stuff. The branch cuts, I might need to read visual complex analysis or something for their explanation of it, but we're starting to wrap our heads around it. It's like AMAth 567. I can find it exactly in a minute. Sections 2.1 to 2.2. We'll shoot for the rest of the content without a star in chapter 2 for next week. 2.3 to 2.6.1. 2.4, not 2.3. Okay. Period. Oh man, there should be an orientation in like 2 weeks or something. I have not even thought about. Here it is. I wonder if they've actually said the textbook. Turn into a much larger project. The scope is creeping in. Ooh, for summer math exposition. I need to. It's been a minute since I've even thought about making sure I'm ready for, like, I mean, like registration wise and all that stuff, for grad school. Because I think there's an orientation sometime in June that's like online. I need to actually figure out if that's the case. Hey, Sound of Serenity. Okay. I did get the copy of this, right? I did. Yeah, if you want, there's a link there. It seems like really interesting stuff, but I definitely need to prepare for it. I wouldn't expect to succeed if I just went in cold. The collar cone throne. That rolls off the tongue. You able to prove the proposition you're struggling with? I showed to the collar cone who is the real collar cone. Okay, let's work on number 7. The one that... Oh, wait. I did promise Rayan I'd work on a question from them. Let's try with Rayan's question, I think. So I can always do the complex analysis stuff off stream. I told Rayan to check the recording, and so I should actually do something with it. What is edXL, Sound of Serenity? I haven't heard of that. This is kind of challenging. Oh, they did make a correction. Let me look at what you're talking about, Sound of Serenity. Are you asking about this one with the rationalization? 22? The turning point on the curve. Is that the vertex? Am I on the wrong thing entirely? Wait. You're giving me a completely different one now? What do you actually want to see? you talking about this one? Okay, this one. Let me see how long this is. Let's see if we can do this one quick, and then I'll go back to the multivariable thing. Photofuth? That's a funny name. There's a few questions that are stacking up. I'll give you a quick. If you want to do the integral of sine of x over cosine cubed x dx, I'll give you the first step here. Take u equal to cosine x. Du will be sine x dx. And so the u sub will give you just 1 over u cubed. And I'll let you take it from there, but this u sub is the key step in that problem. There's a few questions are stacking up, so I'm sorry that that's a quick explanation, but I want to try and help. Yeah. I'm not explaining it well, but just try to get you an answer quickly and not make you wait. AB is tangent to the circle at point A. OBA is 30. B 16 0 P 3PP. Find the value of P. What? It is, Jed. It's finally your time to shine. Now, I'm immediately confused. We don't need the entire lower half of this. They're just asking us. Oh, we need to find the radius of the circle. That's why. We already know the ratio of the sides, like Jed is saying. It's been a minute since since we've had a geometry problem for you, Jed. I'm glad that you're here for it. So Jed is pointing out this triangle down here is 30, 60, 90. And so 30, 60, 90 triangles. The side lengths are 1 to root 3 to 2. And so cutting out OBA and drawing it separately, we know this side up here is 16. We want OA. And so we know the 90-degree side is twice the 30-degree side. So I agree with Jed. OA should be 8. And the reason we want that is because that's the radius of the circle. So now we know this thing that's also radius of the circle is also 8. And so we can complete a right triangle here. And the x-coordinate 3p will be the bottom part of the triangle, and the y-coordinate will be the side part of the triangle. Oh, true, yeah, we can just Pythagorean theorem. Let me just redraw it down here. Three P and P. So yeah, this is a right triangle, so let's just Pythagorean theorem our way through it. 8 squared equals P squared plus, the parentheses are very important here, 3P squared, squared. You get it? Awesome. I'll still follow through with all the math, but if you get it, feel free to start paying attention. Plus 9p squared. 64 is equal to 10p squared. Divide each side by 10. 64 over 10 is equal to p squared. Take the square root of each side. We don't need a plus or minus because it's a geometry problem. We get p equals 8 over root 10. You could rationalize this. You probably, I bet they want you to rationalize it. So multiply by root 10 over root 10. And that simplifies to 4 over 5. And so if you don't know that 30, 60, 90 thing, you can always use trig to figure it out too. But if you do know it, it saves a lot of work. I am, Zach. We're not doing like differential geometry where negative distances make sense. Thank you, Jed, for the carry there. Yeah, the trig can take a bit longer because you have to remember like the unit circle and stuff. Or break out your calculator. No, you're not dumb, Son of Serenity. I would have had to look it up if Jed didn't just tell me it. Morianch, I see your question. I don't quite know. I don't think I know how to do that one though. A middle step between, hey Frank, a middle step between knowing it in trig is seeing it as half an equilateral triangle. Oh, yeah. A 30, 60, 90 triangle is half an equilateral triangle. Yeah. And so that would give you immediately that that side there is half the other one. So Riemannian manifolds, the metric is positive definite. You can't put screenshots in YouTube chat. You can put them in my Discord though if you have Discord. Morianch, I don't know how to do your problem offhand. I can Google your problem. I know how to do that. Crayons? You know, I'm just going to say that you probably know how to Google it yourself because I can't immediately find a website that I like. It does seem there's a lot of YouTube videos and things on it, but I want to work on this question up above here. Or I guess if Sound Uncertainty has another one, we might work on that one. For whatever reason, people have started just like counting in that chat. Feel free to ignore them. You can put it in math discussion. Or you can put it in, you can make a thread in math homework help. Either one works. Hey, Bravo Snipes. Okay, we have another question from the same sort of test. From Sound of Serenity. After this one, Sound of Serenity, I do want to work on this one. The person isn't here right now, so it's not that time sensitive, but I do want to work on it today. No, you're okay. We can do this one too because these, I'm guessing these are going to be quicker questions. But after this one, I'm going to take a little break from your questions. You're not doing anything wrong. Okay. For one revolution of the wheel, oh, they... I was wondering why that little tail is on there. It's because they cut the tail off of that piece. Why would you cut it up like this? Maybe because that's the origin. I don't know. But like, I don't know. Okay. The maximum height is 50. The passenger is 1 meter above the ground when the wheel starts turning. It takes 720 seconds to complete one revolution. Find a complete equation for the model giving the exact value of A, exact value of B, value of alpha to 3 significant figures. Okay. Well, if we think about the general sine function, you might have A sine B x minus C, like this. Here, A is amplitude, which is the maximum value or minimum value that, well, no, that's not a good way of saying it. It's the height of the oscillations. So if you have to like look at the baseline of the sine wave, whatever that height is there is your amplitude. It's like the minimum or the maximum, but that's not a perfect word. So I was trying to avoid that. Yeah, exactly that, sen of serenity. And so, I think they're just straight up giving us in the first bullet point that it's going to be 50. And so the ground is the baseline here. And so the maximum height above the ground is going to be 50. So I think we can safely say that 50 is going to be our amplitude. B is either the period or the frequency. I don't remember that offhand. I always... Ugh. The period is 2 pi over b. Actually, am I writing it? Should the b be factored out? No, it shouldn't. Or yes, it should. I mean, and then C is the phase shift. And that shifts the entire wave left or right. I did leave off. You can have a vertical shift too. It's not important for this problem, but you could have like a plus D, which would be your vertical shift. Here we're measuring height from the ground, so we're not going to have one, but it's possible to have that too. Nope. Here we go. Okay, so now there's a little distinction in this problem where it's the absolute value of this kind of sine function. So, and what all that represents is sine, unless you shift it vertically, sine always has negative values. They're getting rid of the negative values by just taking the absolute value. So like this negative part down here is going to suddenly flip up and become positive. And that just reflects that, you know, we're never going below the ground. That everything else is going to apply as normal. So in starting to fill in, t is our variable. Our amplitude is going to be 50 based off the information that we're given. Bt plus alpha. And so if the wheel takes 720 seconds to complete one revolution, that's the period. So we know 720 is equal to 2 pi over whatever number is in front of x. I had the capital B up here. They have the small b there. Either way is fine. But we can solve this equation for b. It'll be pi over 360. They give us a nice round number there. Oh, this is in radians. Bruh. How do we deal with putting it in degrees? Because they're specifically saying this is in degrees right there. We just do the conversion factor thing, I guess. It's something involving pi over 180. Probably 180 over pi. Yeah, okay. So they're simply doing things in degrees, which is annoying. But they had the little degree symbol right there, which is what's scaring me. How we can get it in degrees by multiplying it by 180 over pi. So that'll be 1/2 of a degree. So our height function now going to be 50 sine 1/2 t plus alpha in degrees. So we just need to find alpha, and the only piece of information we haven't used yet is this second bullet point here. So let's use that and plug it in, because 1 meter is a height, and when the wheel starts turning is a time 0. So h of 0 is equal to 1 is equal to absolute value 50 sine 1/2 times 0 plus alpha. So we get 1 equals 50 is a positive number, so we can just bring it outside the absolute value and not worry too much about it. That's 0 plus alpha, so alpha. Now we divide each side by 50. And then with solving this, the one we're going to care about I think we can just drop the absolute values. Like we care about the first time sine reaches a value of 1/50. And that happens when it's positive anyway. So I think we can safely drop the absolute value bars and know we're going to get the correct answer. That part's a little bit hard to explain though. And so I think now it's calculator work. Alpha's arcsine of 1/50. Do they give us restrictions on alpha? Not that I see, just that it's a constant. Eigenvalues on a matrix, Abinand. The basics of them, I don't know if you have a specific issue. A3 FDS would solve both cases and choose the positive value of alpha. Maybe. Thank you for the kind words, Joe. 750? Oh, nice. Let me look at what you said. This is the solution they gave. Linux is awesome. Any alpha up to addition multiple pi. Yeah, I imagine it wouldn't make a big difference. So they do just drop the absolute value bars. Wait, they got a quarter? Most complicated concept? Probably like differential geometry and like I've been learning it in the context of general relativity. And just working with different line elements is really freaking weird. I got the right answer for B. It doesn't affect the answer for alpha. I did everything right except for B. Oh, did I get tricked by the absolute value? I did. Oh, okay, so the mistake I made is that regular sine of x has a period of 2 pi. But the absolute value of x, when you flip that part up, this hill looks the exact same as that hill. It's now like you can cut it in half and it's now periodic just in pi or 180 degrees. Man, that's such a tricky thing. Because you can think about it as being a passenger on the Ferris wheel. Just between 0 and 180 degrees, you've started at the bottom, gone all the way up, and then come back down. Just in the 180 degrees. And so that's why the answer that I got assumed... The answer that I got missed that. I needed to cut my answer in half again because of that. Other than that, everything that we did here is legit. So like I would say like just equal to pi over b. You understood it? All right. I'm glad. I wish I did it right the first time, but I'm glad I could help you. Doesn't that remove everything 750? Like your entire file system? Okay, so I really want to work on this multivariable question up here. It deletes the French language pack? Oh, funny. I don't know that I've done... I think I need to Desmos this. I want to see what this ellipsoid looks like. Egg. And so inside of this ellipsoid, I'm going in. We're drawing a cube. A cuboid, which I assume is like a rectangle. So that's going to put constraints on the coordinates, right? We need to figure out what those coordinates must look like if they lie on the cube on the ellipsoid. The cuboid will be centered on the origin. And so that point right there. Well, I do need axes. Yeah, I was just debating how to split things up in half. The twice bit would save us a bunch of fractions. Okay, so this point right here, we can actually give coordinates to that point. Right? Is that the Riemann zeta hypothesis, AJ? Okay, I mean, there's probably not a point in writing out the coordinates of each of the vertices, but no worries, AJ. Thanks for the kind words. A cuboid has equal side lengths? Oh, really? I was assuming cuboid can be all three unequal. I didn't actually Google it. Each face is a rectangle. No, I think they can all three be different. Um, what else do we know about this? We want to maximize the dimensions of the cuboid. I assume that maximizing the volume would accomplish that. Yeah, A3FDS. I was just wondering the exact same thing. Surely it's the volume that would do this. Yeah, I think this is gonna be a Lagrange multiplier question at some point, but we need to get things where we want them. To be honest, I'm getting a little bit stuck though, because I want ABC in terms of X, Y, and Z, right? How do we do that? Hmm. Oh, maybe we don't. Oh, I was trying to get ABC and XYZ, and it was really not making sense. But you're right. I should be going the other way. Okay, and so that's something that we can Lagrange multiplier our way around, right? Paul, teach me Lagrange multipliers for the at least 10th time. Del F equals lambda del G, where G is the constraint equation. Ooh. You're calling it Femvox, okay. That would make sense. I was noticing it's like a progression of perfect squares. It does feel like it should be a kind of nice answer, like what you put there. Oops. So uh I don't know why it would be that A3 FTS. I guess. RVP, I'm not sure how to do that one. So we want the gradient of volume. It's weird doing this with A, B, and C. The gradient of that thing. That I'm calling G. Aren't we missing an equation? Oh no, we also have the original constraint equation. So we now have a system of equations 8bc equals lambda a over 2, 8ac equals lambda 2b or not to be over 9, 8ab equals lambda c over 8. Plus the original constraint equation. Oh, there's many solutions. Now this is a little bit disgusting, isn't it? Maybe we focus on plugging things into this equation. Like, can we get rid of A and get... maybe we can't. We can eliminate lambda pretty quickly. I like the song. Student Academy. Yeah, I can't really... You don't have enough information to find A. 2G network. I think that's... I would just plug it into Desmos. Multiply by ABC. I'm from America. Multiply these equations by ABC that I just wrote. And you want to take the square root? I don't know what that accomplishes. Can we just get rid of everything we can? I think this is an inefficient way of, well, I don't know. We can get rid of an A, B, and C though, right? No? Oh, you're right. Wait. Did I mess something up because there's 3 equalities here? Should I just break it out into 3 separate equations? Something about that does feel wrong. It feels like it conflicts with that. I didn't? I didn't cancel things that should have canceled. I have no clue what I did wrong. Is this not correct, what I wrote here? Oh. Yeah, I don't know why I did that. All my to the ones should just not exist. That's what you're saying, to take the square root. Okay. We can divide out an 8 as well. Actually, no, we don't want to do that if we're going to square root. But honestly, maybe instead of square rooting, like, we need to deal with squares anyway at some point. So maybe it's time to get 3 separate equations here. Or, yeah, 3. Just delete the c squares automatically. Let's save ourselves some writing. From these 2. You know what? I do want to cancel the 8s. Wait, oh, 8 doesn't go into 36. Never mind. Dude, it's a crime that 8 doesn't go into 36. Whoever made math really needs to patch that. I just feel like 8 should go into 36. Tell that to 32, yeah. Square root is the way? But we have to do squares up here anyway. I don't know. Or are we only working with these? These are... They just announced the new patch. Hamiltonian Amos does not want the square root. We can cancel the 4, that's true. I need to do that one and that one. Okay. Terrence Howard made 8 going into 36. Well, then he is a hero. That's a joke, by the way. Oh, wait, so we can make this just an equation in A. That's the play. Because B squared is certainly something. 9A squared over 4 over 9. C squared. 4A squared. Aha! I got you trapped now, A. I'm not Canadian. I'm just talking to A, the variable. I make myself laugh. Oh, we are getting a square root 3, right? Because you know how Canadians say like, "Oh, you want some maple syrup, A?" But I wasn't saying A like EH, like Canadians say. I'm saying like A, the letter. It's me being dumb. Is the moral of the story. I assume we're not going to need minuses. But just to be complete, I'll put the plus or minus. Okay, we should be able to get... Do we even need lambda? No, I don't think we need lambda. Because these are the candidate. A, B, and C are going to be our candidate. Or any solutions from this are the candidate. Yeah. Okay. So then B... lambda can get in the bin. Yeah. Well, that's a stereotype about Canadians. I don't know if it's only a part of Canada that speaks like that, or if it's just like South Park did it, and now all Americans think Canadians talk like that. I'm trying to think of the... No, the Canadians that I have talked to, they might drop the occasional A, but the stereotype is that they say A all the time. I'm physically incapable of doing mental math in this instant. Just root 3 for B? Okay. Okay. So it doesn't make any sense to have... Oh, gosh. It doesn't make any sense to have negative lengths here. So we only get one candidate solution, and I sure as hell hope that's our maximum. It's not going to be a minimum. The minimum would be 0. We can test this, right? We have the technology. That's not the right window. The C needs a 4? Let's compute the Hessian. Let's not. The C needs a 4. Oh, it sure as hell does, doesn't it? It turns out 4 times 4 is not 1. Newsflash. These should translate directly into coordinates, though. We can just take those. Oops. Wait, that's not it. This is it. Okay. Oh! Our oval has a pimple. Puberty's rough, isn't it? Hell yeah. And so then everything else is gonna be some like permutation of the signs with this. Hell yeah. Oh, you did call it Fembox. Did you just figure that out by looking at the equation for the ellipsoid? Okay, so there's the second part of the question, which is the circumscribed cuboid. I assume that's the cuboid that goes on the outside. What's the smallest one you can make? Oh wait, I was gonna say think that's really hard, but we can do that geometrically. We don't need calculus for that. We only need the lengths of the axes, right? I forget what they're called for ellipsoids. But like, you only need the width in the x direction times the width in the y direction times the width in the z direction. I didn't do the z direction right, but you know. Nobody, I sure as hell don't. Proof by Desmos that it's maximum. When you want to optimize the sum of terms, often each term ends up with the same amount. So I just set each to 1/3 as a guess. Funny. Okay. So wait, what? We should be able, like, oh, may always hate the second derivative test? Yeah, it doesn't even work all the time. Well, the Hessian does work all the time. Well, no, it can be inconclusive. Yeah, the Hessian can be inconclusive if the determinant is 0, right? So I'm going to say this is much better done geometrically for the second part of the question. One dimension of the box will be 8, the length along the x-axis. The other dimension of the box, is that going to be 18? 1, 2, 3, 4, 5, 6, 12. Why is it 12? I don't know. We don't have a scale for the z. Bruh. If x and... Oh, wait, that's 4. I forget... I already forgot the other numbers I said. Wait, it was 8, 12, 8, 12, and 8. That's going to be the minimum circumscribed cuboid, I guess. I would not use calculus for that. Okay, Flare, you put up some weird series. The egg looks delicious, hell yeah. You don't think the grid lines are length 1? That's a 5 there. 1, 2, 3. No, I think they are. Wait. Oh, when I was zoomed in, they weren't length 1. Now they're length 1. I was really confused because like I thought it should be correlated with these denominators and they weren't. So wait. Okay. So it's 4. Oh, you have to square root it and multiply it by 2. That's the pattern. So 4, 6, 8 are the dimensions of the cuboid. Flair, I'm not sure how to do that question. Student Academy. That just looks like a tedious one. If with enough practice, I could probably do it that quick, but like that's just I don't know. They just make you do a lot of work for nothing. Naveen, you have a question. Given secant, I'm just gonna call it theta, but it doesn't matter what goes here. Is 13 over 12. Get all the other trig ratios. We can do that. So secant is 1 over cosine. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So let's draw a right triangle. Third time's the charm. That's our theta. We can name either one we want theta. Hypotenuse 13, adjacent 12. I'm pretty sure this is a 5. Yeah, and so you would solve for this remaining side with the Pythagorean theorem. 13 squared is 12 squared plus, I'm just going to call it b squared. 13 squared is 169. 12 squared is 144. Plus b squared. Subtract the 144 over, you get 25. And then square root each side, you get b equals 5. So now we know all 3 sides of the right triangle. Hopefully the easier part is getting the trig ratios now. So like sine is going to be opposite over hypotenuse, 5 over 13. Cosine, it's just the flip of secant. So you could already say based off that it's 12 over 13. Tangent, 5 over 12. Opposite over adjacent. Yeah. And so cosecant is 1 over sine, so 13 over 5. Secant we already did, or we were given. Cotangent is 12 over 5. So that's how I would do that. Okay. I'm just making sure there's nothing else in my Discord. Let me check this one thing. Debating what we want to do here. Okay. Hey, Mr. Shabam. Is the base 5 or the perpendicular? Did I mess up secant? I'm pretty sure that one's 5. I've been known to make simple mistakes, but I think I did that one right. It'd be nice if I could. Did you post a question, Shibam? What's your question? I can put it there in chat or in my Discord. Inscribed, circumscribed. What if we allow them to be rotated with respect to X, Y, Z axes? Oh. Oh my god. I hope the answer is I think the math that we didn't actually require it be oriented in this way, the way that I drew it. Did I implicitly do that anywhere? I think by virtue of how we use the constraint here, we did account for the rotation. For at least for the inscribed part. Because even though I drew it this way, I don't think it has to be that way. Or I think the math would have accounted for that. Oh, yeah, you're right. I think it would change the V function. I don't know. You might you might be raising a good point there. I'm trying to flip the situation that you're saying, and I'm trying to think about keeping the cuboid the same, but like stretching around the ellipsoid. I don't know what that equation would look like either, though. I imagine like an ellipsoid that would stretch in every possible way would be a lot more complicated than this constraint here. I would love to use a symmetry argument. It was at an angle, you could rotate it around an axis and get the same volume. Hey, Joe Miner. Glad to hear it. Does it have to be unique, though? I can see what you're saying. Where like, if it's at an angle, there's like a complement to it. I know that that makes an issue though, for it to be unique or not. Oh wait, I guess. Maybe that would. I don't know. At least, the questions on the screen now is like, undergraduate math. It's relatively advanced undergraduate math, like second or third year. We would call this multivariable calculus. We've already solved it. We're just kind of discussing a harder version of the question. Or maybe a subtlety with the question. Probably reduced to the case of the sphere. Your cuboid will be a trapezoid. Yeah, it wouldn't be a cuboid necessarily, would it? Well, no, we could require it be a cuboid. Oh! Yeah, you probably can't make a cuboid if you start rotating it, right? You can show the cube as the trapezoid of maximum value. Interesting color cone. I think that's probably the answer right there. You probably physically cannot make a cuboid if it's rotated inside of that ellipsoid. Joe Miner, you can put it there in the YouTube chat or put it in my Discord. I'm gonna wrap the stream up soon though, so if you're gonna post something, do it quickly, please. This is like multivariable calculus, Umar. It's it's like second or third year undergraduate math. If we do a linear transformation from the ellipsoid to a sphere, maybe Territar, I'm not sure. That's what I'm thinking, Femvox, yeah. Or that's what Colorcone was saying, where you get a trapezoid if you do stay inside it. Thank you for the kind words, Doppler effect. A linear transformation from the ellipsoid to a sphere. How will that affect our cuboid? It'll make our cuboid just into a cube, I guess. Oh, Territar. So maybe that's the argument you're saying is that the maximum cuboid that fits inside a sphere is just a cube. Oh, that's why they follow the nice progression, Fembox. Yeah. Oh yeah, great thought, Territar. Wow, that would have been such an easier way of doing this. Do a coordinate transformation. Well, yeah, Hamilton Names, I think the point is that the cube will get stretched the exact same way as the ellipsoid will get stretched. Oh my gosh. Territar, that's a fantastic idea. I'm doing this backwards. On the sphere, you will get a trapezoid. Really? Because from here, I was going to use the fact I'm pretty sure it would be a fact that the maximum cuboid that fits inside a sphere is just a cube. Unless your cuboid are in the three main axes of the ellipsoid. Well, the nice thing about the sphere is that rotations don't matter, right? I'm gonna wrap things up for the day soon. If you can do it relatively quickly, though, you can put it there in chat or in my Discord. But I will have to go for the day relatively soon here. If we look up to linear transformation, the sphere and ellipsoid are the same. The same goes for the cuboid and trapezoid. It gives different shapes when you stretch it out. Oh, that's what you and Color Cone are saying? Hmm. So then maybe the argument is that in order for the cuboid to be preserved under the transformation, it must have that orientation, because otherwise it becomes a trapezoid or it sticks out or something weird happens. Yeah, the question does say a cuboid in particular. So any rotation that would result in a trapezoid, we would say is invalid, I guess. Mr. Shubham, I'm doing one right now from Joe Minor. If you have a question, though, please post it. Just be warned that I may end the stream before I have a chance to get to it. Oh. Hey, Viv. This is kind of a funky one. If we're able to show we can rotate that cube too, that it's now in the axis of the ellipsoid, such that when we map back our sphere, the ellipsoid is still at a cuboid. Yeah, I think there's an argument like that to be made. Interesting. So maybe we need some functions here. The position of n at any time is 1200. I'm taking the origin here to be m, I guess. 0, and this point over here is 1200. So n is getting closer to the origin. So 1200 minus 10 times t. Yeah, sure. Feel free to tell me the topic. This seems like just physics, I guess, like kinematics. I'm gonna say small m for missile. Is equal to 125. We're expected to use vectors. Okay. Wait. What am I doing here? So, yeah, I mean, let's say we have an x and y axis like that. The position of n at any time is that linear function m, comma 0, just to enforce that n is always on the y, it's always on the x axis. The missile, small m, I'll say, at any time, the x coordinate will be the x component of the velocity. So 125 cosine theta, where theta is this angle, times time. The y component will be the equation for a projectile. Which is 125 sine theta t minus 1/2. They say meters per second. So we'll say 9.8 for gravity. Times time squared. For gravity, some people say 10, some people say 9.81. I think 9.8 is the most common though. And so we know that by how the question is asked, we know that there is some time t where these vectors should equal each other. So at the same time, it should be true that 1200 minus 10t, the x component of the first one, equals the x component of the second one. 125 cosine theta t. Same is true of the y components. Oops. So 0 equals 125 sine theta t minus 1/2 times 9.8 t squared. This is a system of two equations with two unknowns. We can solve it for, we're interested in theta. We don't care about time. Rejo, I'm not doing that question, no. So I want to get rid of time from all these equations. What's the easiest way of doing that? I guess we rearrange this one to solve it for time. So 1200, I'm going to add the 10t to the other side and factor the t out. Because I don't want to do it, Rejo. Now we can divide over this piece. And so now we know that t equals this. We can plug it into this equation and solve it for theta. It's going to be a little disgusting, but I'm sure we can do it. Well, yeah, I don't want to do it because it's really hard. That's the exact reason why I don't want to do it. You nailed it. I'm going to factor a t out of this. I think it'll make life easier. So 1200 over 125 cosine theta plus 10 times, hey, Afto, 125 sine theta minus a half times 9.8 times 1200 over 125 cosine theta plus 10. Okay. So this piece here, there is no value of theta that makes that piece equal to 0. Like this is where we split off into two equations. And so we don't get any solutions from this equation, so we have to focus on the other one. Because you can multiply each side through by the denominator and just get a contradiction. So I would look at the other side. 125 sine theta. A half times 9.8 is 4.9. Oh my god. Equals 0. Now I want to get rid of this denominator, so let's multiply through by that denominator. I should say, all of this up here is the real meat of the question, I would say. Everything we're doing now is just execution. But if you understand this part, like that's the really important thing. All the stuff that we're doing here is just algebra. Hey, code forcing. Yeah, exactly. It didn't work out. Oh, really? So if you already set this up, let me just plug what I have into Wolfram. Because this is going to be annoying to solve by hand. And if you already understand the setup, let's just kind of cut to the chase. You see, okay, yeah, fair enough. That'd be cool. Code forcing, yeah. This link isn't working. Oh, I'm sorry, but Fate. Discord just kind of does that sometimes, and I don't know why. I hope it fixes itself at some point, but after, I assume that's going to be 9. Oh no, Wolfram, you should. Hey Yoganch. This seems like it should have a better representation than what Wolfram has. Oh, exact. Oh my god. I regret clicking. I think Wolfram was doing something weird. HN, I'm not sure what KRO is. Atho, I'm pretty sure that's just 9. This is annoying. What level of math is this? Probably like high school. Tech act. Oh, it's all good. I switched that the tech was giving me a different answer. Is there something else I can use? We can Desmos it. Oops, not 2000, 1200. Okay, ignore all this weird stuff. We just want the first answer here when it's equal to 0. Come on, Desmos. Tell me the exact decimal. It won't let me click on it. You could say like 0.38383 radians. Afto, stop. I've answered you twice. It's just 9. And color code, I'll read that in a second. So what is, I'm going to call it 383. Yeah, Hamiltonian. I figured there's like a quadratic we can squeeze out of that somehow. I just kind of didn't want to, but I think that is how you would do it. Wait, okay, so like 22 degrees, 21.9 degrees. I don't know if they prefer radians or degrees. That seems reasonable though, right? I don't know what mathematical reasoning they want. It's the answer? Okay, nice. So yeah, in case you don't know, I multiplied by 180 over pi because that's how you go from radians to degrees. That's all I did there. Actually, if your calculator is in degrees, it'll take care of that for you. I should have unpinned that message. Oops. It's between 0 and 90. That's true. It's a good sign. We find out the timing, we can find out the answer. That's true too, yeah. The timing, it would have been annoying to eliminate theta though. But I guess if you have tech that can do it for you, that works. So what did color cone say? Change our dot product, the metric, to make an ellipsoid into a sphere. The volume function will be the same up to multiplication by a constant. Huh. Change the dot product, or the metric. Is that like, if your line element, are you talking about something like that? I guess you can have as many constants as you want in front of these. Oh, okay. Volume function will be the same up to multiplication by a constant. Okay, and I guess to find the volume piece, you need some kind of integral or something, but I'm not sophisticated enough with this stuff to know exactly what to do with it, but that's an interesting thing. Tribro had like 30 minutes of the exam to do it, still... Oh no! That sucks, Joe Miner. Yeah, it's kind of a... It's a really weird question to set up right. About the ellipsoid problem, if you apply rotation transformation to the ellipse and solve for the volume as a function of theta and phi, keep the cuboid aligned to the axes, but rotate the ellipse. Okay, fair. I still really like the direction that we took with it. The volume function be given by the determinant. Oh. Like a Jacobian type, like idea or thing. I know it's related to the Jacobian in some way. Okay, that's a really cool direction to take that question. Probably not the intended way for, like, I'm assuming that like the student who's being asked this question is supposed to use the Lagrange multipliers, but this transformation way of thinking about it is kind of cool. It's fun to think about. Okay. I think this should be the end for me for today, though. You made so many horrendous arguments in your master's thesis. Oh no. Okay. So yeah, I think we'll cut things off here. This has been a really fun day. On Twitch, we'll look for a raid. On YouTube, I'll be back on Thursday. I'll be back late on Thursday, though. I have a doctor's appointment. It'll be like Thursday, like add on like 2 hours or something. So yeah, Joe Miner, welcome in. If you have more questions, the only person on YouTube who does this, there's Dr. Gold, or actual education as well. So if anyone wants more math help, he exists too. Krishu, hello and bye. I'm sorry I'm about to end the stream. No worries. Proximity gaming, I'm sorry, I won't be able to help you right now. Wait. Yeah, that's how we did the question for proximity. Tomorrow, it'll be in 2 days, starting 5 hours ago, whatever that is in your time zone, HN. So yeah, goodbye YouTube.